And I'll just see if I can record too. Beautiful. Okay, so hopefully you've got these little assets. So what we'll do is, if you have your own, you're welcome to use those, or you can change them and edit them as we go along if you just want to kind of watch this rather than follow along. So just download them. I've already got mine saved onto my desktop here. Now I'll open them very quickly in Photoshop, but I think they're PSD files, so they should be fine in Unity, which we're going to be using for this. If you don't have Photoshop, don't worry. Unity can still handle loading it. But again, if you have problems, let me know. Okay, so what we have here is a kind of basic sprite sheet. So if you haven't seen a sprite sheet before, the idea is that you put lots of images all together on one image rather than on multiple images. And there's a little bit of like a technical reason behind that, and it has to do with the way graphics processing units work, or GPUs. Hopefully you've heard of those from kind of all the real like gaming enthusiasts who tend to want to get the best GPU possible to get the best performance in their games. But in terms of like programming, we kind of think about what is a GPU capable of, and then we work out backwards from there how to make performative or optimized games. So in this case, I've just put them all on one sprite sheet for ease of use, and also to show you how the sprite editor in Unity works. Great. So can I get an idea just from the chat who's actually following along and who's just kind of watching, if you want to? And that way I can kind of give more pauses and breaks to see how you're all going. I wonder if there's a bit of a delay between Twitch streaming and this. A couple people just watching. Okay, cool. I'll just crack on with it then. And then if you need a break or you have any questions, just chuck it in the chat channel, and we can kind of adapt based on that. Great. Okay, so first things first, hopefully you've got Unity installed as per the little indication on following along. So we'll open that up. Unity versions, so if you have a different version, don't worry too much. The big thing is if the first number is different, so if it's a 2017 or 2016, they tend to have very, very different version numbers. Sorry, very different features and slightly different ways of programming things. They're not super hugely different, so you can convert code between them, but they do have little oddities that can make it a bit annoying. So here's what I tested with before. For you, if you're following along, you can make a brand new one, so just a new project. You might have to sign in with Unity first. Just tell them it's all a personal project, I'm going to call mine Little Garden Game. And I'm going to make that 2D. So the differences between 2D and 3D are actually very surface level. So if you do choose the wrong one, don't worry. There's actually a lot of things you can do to kind of switch it back. And some games hybridize between the two. So one title I'm working on at the moment called Intergalactic Space Princess is a hybrid between 2D and 3D. And so the template you use doesn't really hugely matter. Okay, great. So we'll create a project. I meant to put it there, but I didn't. Oh, that's okay. So put mine in my document somewhere. Does a little bit of thinking, working out what it's doing. And then it should launch us up into the full editor. And I'll talk a little bit about how Unity kind of manages itself. Thank you, Doom Bunnies, who did a little shout out to ISP there. Thank you. Okay, cool. So it opens looking pretty much like this. So we've got this thing called the inspector on the right. We've got this big, if you've never worked in 3D or used any kind of animation tools before, you might be like, oh my goodness, what is this? This is our scene editor in the middle here. And we have a hierarchy on the left and then our project down the bottom. So these all have slightly different purposes, as you might expect. So the scene will show us what's happening in the world. And if we click on something in the hierarchy, you can see that change something in the scene. It relates directly to what's happening in here. So let's say I'll just make a new object just as an example. So I'll make a new cube. We can see that has appeared in the scene, and it's also appeared in the hierarchy over here. So these two areas mirror each other. They completely reflect each other. And if you want to find something in one of them, if you're like, oh, I wonder what that is, and you click on it, then it highlights it here as well. Now, this is a really important way of navigating in Unity. If you haven't heard this one before, the button F will focus on whatever you have selected. So that's really cool if you're like, oh, I wonder what this object here is and where it is in the hierarchy. So it goes both ways. So if I have my mouse over the hierarchy and I press F, it highlights it there in the hierarchy for me. So it's really good when you have complicated scenes, which won't be too much of a deal for us with this little tutorial, but it's just a really good thing to know. So you might notice me kind of moving the scene around here. That's just done with the mouse wheel, so scroll in and out. And then if you hold Alt and then drag around, it moves you around. And this is in the 2D mode. So like I was saying before, the template is just kind of a template. It's a guideline. You can change between it. And one of those things is by changing this 2D toggle here. So switching that out turns this into 3D, which we're not going to make a 3D game, but if we did want to, that's how you would see that. And movement is kind of similar in that you're still kind of panning with this is Alt and click. While in 2D, Alt and click just kind of moves you moves you on this 2D view. Alt click here, or Alt drag, I should say, moves you around an object that you have selected. So in the case of, again, selecting a different object, so if I select the camera and I hit F, it'll jump me to it. And then if I Alt around, it actually rotates me around that object. But we'll do 3D a bit more another time. So let's go back to 2D. I'll get rid of this cube and we'll bring in our own art. So there's two ways you can import art. Actually, sorry, let me step back a little bit. So these things here are what's happening in our game. This is our scene. You can think of it like a level. The stuff down here, so this scenes folder that it's come with, and if you're opening a project you already have or something like this, there'll be more things in there potentially. This is our project view. So in here we see everything that could ever be in any level. So if we think of a game like maybe Mario, for example, you could imagine there might be the Mario character art, there might be some mushrooms, there'll be some coins, all little bits and pieces that make up that level will be in the project. And then when you build the level, you're actually building from this project pane into the level in here. So let's get right to it. There's two ways to add to it. One is you can right click and import a new asset from the project pane. So you can do it this way. So if I do that, I'll just select my assets and import them, and they've popped in. The other way, which I prefer just because it's a little bit maybe less clicks, is you find where the asset is and you just drag it right in. And you'll see it's duplicated the same file twice in this case, and it's just renamed it, which I don't want. But you can use either way to get your files in. Let me just tell off Ollie for a second because he's licking his paw. Ollie. Good boy. There we go. All sorted. Great. Goblin Deluxe, I don't think you need to worry too much about using a mouse in 2D. It's more of a 3D thing. I think you can also right-click to move around to pan in 2D as well. That was me not explaining fully. Okay, cool. So we've imported this thing. If we have the 2D template selected when we made our project, it will import as a 2D sprite. Now, if you had 3D selected, it would actually import it as a different type of thing here. So we'll notice when I've clicked on different things in this world, information has changed in the inspector. This is basically our detail view. So whatever we're looking at, whatever we have selected and highlighted, tell us more about that thing. That's what the inspector does for us. So with the garden selected, the garden sprite selected, it's imported as a sprite 2D. Oh, confusion over Ollie's. Very good. No, Ollie, my little pet Ollie, not Ollie, the lovely human Ollie. Okay, so if you accidentally selected 3D or you're working in a 3D project but you want to have 2D sprites using, again, Intergalactic Space Princess as an example, you just need to change it from a from default, which is I think just a texture, a plain texture. So used for 3D, if you know anything about 3D modeling or 3D applications, you'll have like a 3D mesh that you then apply a texture to. So the default state is that Unity expects you to be making a 3D game, and therefore it will attempt to import any images as though they're supposed to be applied to a 3D mesh. When you're making a 2D game, that's not what you want. You just want to have the image straight up as it is. However, in our case, and like with a lot of games, it's not straight up as it is. It's not precisely the way it comes. We actually want it to split these up into different images. So let's go ahead and switch this to multiple. So sprite mode has single, multiple, and polygon. We're not going to worry about polygon. We're just going to look at multiple for now. So there's a little bit of differences that kind of appear there, which we don't need to worry about. And all this information, all this stuff in here, it can pretty much stay exactly as it is, unless you have some particular bug that you want to solve, but they're all a bit more advanced. So I've changed the settings, so it wants to apply some information. So if I click off it, it will say, do you want to apply information? I hit apply. It won't appear to have done anything, except you notice that I can no longer click out here to see all the sprites. So this is because it's realized that actually it's multiple sprites. It's not just one sprite on this image. And so I have to now manually go into it and work out which sprite is which. Or there's other ways of making it a little bit smarter as well. So how I do that, that's with the sprite editor. So I click on that. Hopefully this isn't too small. There we go, that's a bit better. And this has the same controls as 2D view as well. And I can try an automatic slice. Ooh, if you can see that, it's very subtle on this screen. Oops. But it's made all these little shapes. So it's automatically gone, oh, here are all your images. Let me slice that up for you. So that was with slice automatic, and I just hit slice. And that automatically looked for the edges of everything and decided that that was where I wanted to have my sprites end. So I can now click on each of these, which is pretty handy. I can click on them and go, okay, this is my dirt patch, or maybe dirt with seed. This is my normal dirt. So I can name them all. And I do recommend naming things. This is my plant. I'll call it plant 1 because it's really small. This is plant 2. It's a little bit bigger. This is my magical pink berry. Pink berry. And this is plant 3. Now you notice there's this little green one. I'll just zoom in on that so you can see it a bit better, hopefully. This little green doobie. So this is actually the collision, I believe, or the border of the sprite. So generally we just want to move the whole one around unless there's a reason to change the border of the sprite. So you want to move the whole outline. And if you find that the green one has got a little bit shuffled, that's fine. Just move it back up to the edge and it will lock out. It can't go further. So what you want to do when you do this is kind of map each of these as close as possible to the shape of the sprite. We don't want to have wasted extra pixels on the edges. When you're starting out, it doesn't really matter if you have that, but certainly if you start making games for mobile, or if you want to have lots and lots of things on the screen all at once, it's just good practice to make sure that you're kind of cutting things off right where they need to be, and you don't have any extra dead pixels that are just empty and blank. Oh, okay, the kite, let's see. So, okay, yes. Pause. Okay, how to slice. So just to go over that again. So we open the sprite editor. Let me just apply mine. So you open the sprite editor. Make sure you've got, oops. That will only appear if you have this set to multiple. So make sure you've got this on multiple. Sprite editor. It'll pop up here. And then you can go slice and automatic. Just leave all the settings as they are and hit slice. And it should do it automatically. If it doesn't for some reason, then you can make them manually. You can just drag into the space and it will just create one for you. Now I also have lots of little artifacts, which you might have too. For the most part, you can ignore them, but it's best to delete them so you don't get all these weird extra little things hanging around in your image. So I think that's all of these ones looking good. Yep, they're all selected. I'll just double check I've named them all. This is like a big dirt patch. I'll call it dirt patch, that's better. Oh, and actually what I'll do with these ones, this one, so I'm just going to bring this, I'm going to crop this one in a little bit. And that's because I actually want this to kind of be repeatable and to be able to chuck it in the earth of my scene. Move this one in a bit. So dirt with seed, normal dirt. This is ready for seed. Oh, there's some more little weird things that I missed before. And if you do want to follow along, but you're getting a little bit lost, don't worry. I will put this up on YouTube afterwards. I'll do a little bit of formatting and put it up there. And I'll also export all of this stuff into nice Unity package files. You don't have to worry about doing this slightly tedious sprite stuff. Okay. water stream. The other thing I kind of want to demonstrate in this is just the thought processes I have, and to know that if you think you're maybe overthinking something in code or in an editor, you're probably not. There's lots of ways of approaching problems. There's no single way to win, single way to create. So this should give you an insight into how I create things and how I think about making things in Unity and how I think about programming. And then hopefully that can give you a little bit of an indication on where you can kind of take your own direction of code. That's what I love anyway. See, sort of shovel. I would love to be the Bob Ross of programming and games. That's my goal. What's this thing called? My brain's just stopped. It's a Sunday night. Watering can. There we go. Beautiful flower. I think that's all. Okay, great. So we've got them all done. So I'm just going to hit apply. And it's kind of just looks like it's changed stuff a little bit. Just kind of pop the camera out to show me it's done a process. And I can check if they're all right by closing this and seeing, like opening up this little icon in here again. If you can't see this, it might be that your view is a bit different. So if you're in one column layout, it might look like this. And you can see them all here instead. And if you can't see this thing on the side, it could be because it's minimized down the bottom. And if that's the case, oh, you can't see that. Sorry, my screen's a little bit not quite in the camera view. Sorry, let me fix that for you. There we go. Okay, if you can't see that, the side image for some reason, that's probably because of this little weird click on this and it just kind of pops in and pops out. It's a helpful feature, but often I'm like, where's my image gone? It's like, oh, it's just decided to hide it for me. Thank you. So I quite like the 2-column layout. I find that a little bit easier to read, but sometimes I also like to just see the names of things, usually when I start to actually program. Well, I can see I did miss a bunch of items here. That's why I have these weird blank spots, but that's fine. I'll just leave those around alone. All right, so how do we actually put this in our game? How do we start making our scene? So what I'm going to do is show you the game view, which at the moment looks like nothing. And then I'm going to pop maybe a dirt patch in first. So I just drag that straight out of there into the scene. You can't drag this one, or you kind of, oh, apparently you can. Never mind. That's done some weird things. Oh, so that's assuming you're making an animation. So you don't want to drag this whole thing because it will think that your sprites are actually part of an animation, which I mean you might want to do if you're animating something, but for this purpose, if you're using these sprites, they're totally not an animation. So we'll just drag in one of them. So just drag it straight in. And then in the game view, you can see that it's popped up and it's changed them. So I'm just going to lay them out a little bit to make a bit of a dirt patch. So if you want to change the mode on it, so if you want to change stretch, you can just stretch it and move it around. If you decide you want to rotate or use the more kind of traditional 3D tools, you can press, just like in Maya or some other 3D application, you can press W, E, and R. So W, E, and R. They change between these different gizmos. And yeah, if you haven't seen those, they are really, really common in 3D applications. And basically each of these little lines represents an axis. So the first one is giving us transform, so movement in space. And you can click this little square to move in any direction or in just one axis. The E is rotation. So it looks really strange because we're in 2D. So really the way you'd probably rotate it is this way if you wanted to. But I'm going to leave them flat. And then the R is the scale. So do you want it to be skinny or do you want it to be quite wide? And you might notice, not sure if anyone has, but you might notice that actually there are some numbers changing in the scene as I do this. And that's up in the inspector up here. And we're going to talk about this a little bit later when we look at actually programming these numbers. But if you want to be very precise with it while you're building your level, you can just change that by scrolling it. So you can click on the X and drag or the Y and drag, or you can just type a number straight in. I'm going to go back to 111 because I want mine to be nice and uniform. And then I'll click on that one in the middle to do that, to scale it up. And I'm a little bit lazy, so I'm actually going to select both of these. So just like you do in most other applications, you can control click to add or remove things from a selection. So I'm going to select both of them. And then I'm going to Control-C, Control-V, copy and paste. And now I've got a set more. And then I'll just do one more. Control-C, Control-V, and move it across. So now I have a nice little dirt patch. If I go into my game, there it is. Beautiful. So this is getting a little bit messy on the side here. So what I would normally do, even at this stage, I might wait a little bit later, but at this stage I think I would do it, is I'm going to make a new game object. So I haven't talked about this yet in all these systems. I've talked a little bit about the numbers we have in the inspector, but I haven't kind of talked about this whole way Unity works. Now, one really important kind of note around making games and game engines is that, and it's a bit unfortunate, but a lot of games are focused around jumping and shooting and physics and enemies and experience and very kind of aggressive or twitchy type things. Now, this means a lot of game engines are focused around that too. So for Unity, it's quite straightforward to make something that is kind of about colliders and collision and physics and movement. And it's a little bit harder if you want to do something that has dialogue or text or multiple like branching choices or maybe complicated character interactions or something like this. So with that in mind, every time you approach a new engine, whether it be Unity or Unreal or Twine or Bitsy or anything, when you approach a new engine, like there's no such thing as the best engine. They're all around what you want to make. And so it's very uncommon and in many ways unwise for someone to suggest that to kind of go, I want to make a game in Unreal, and then to think of the game idea later. The only times when you might do that is say you have a team who's already specialized in creating something in that engine and you want to work to people's specialties. But for the most part, you work out the engine kind of after you've thought about what your game might be. Unity is used really commonly because it's even though it's still quite focused around collisions and clicking and stuff like this, it's more flexible than some other engines might be. For example, CryEngine is completely made around, it's like a beautiful first-person shooter island engine, basically. So it's very, very good at foliage and very good at having characters who can jump into cars and drive around and shoot things, but it's very poor at a lot of other things. Okay, so with all that said, there's a little bit of background I'm going to give you, but for now, what I'm going to do is I'm going to make a new game object. So game object, create empty. This gives us this new thing called game object. And if we look at it compared to the dirt patch in the inspector over here, there's a few little minor differences. So hopefully you can all spot what that is. The dirt patch has this thing called sprite renderer on it, whereas the game object has nothing. But the game object does still exist in space, so I can move it around just like I did before. I can even change the rotation and the scale, and that changes those numbers just like I did with the dirt patch when we were moving them around before. But in this case, it's not really visible to us, and it's not really clear why you would change those numbers at this point in time. So what I'm going to do with it, actually, is move it down to the center of my dirt. And I'm going to select all of my dirt patches. So as I mentioned before, you can, just like other applications, hit Control and then tap down. Or you can select the first one, hit Shift, and then select the last one, and that will select all of them. Then I'm going to drag them into the game object. And now I have this kind of, as you expect, a hierarchy or a parent-child kind of system. Now that means if I move this game object, it moves everything underneath it. Just like that. Again, this is a really common thing in 3D applications, whether it be modeling or other game engines or visual effects and stuff like this, as it kind of helps us have greater control over things. Now, in the case of this, you can think of it almost like a folder. So if I move the folder somewhere, all of the files inside the folder move as well. Okay, and now I'm going to rename it just so I know what it is. I'm going to call it dirt. Beautiful. And then I'm going to put some, actually I'm going to put dirt piles on top. I will put this normal dirt on top. I'm going to make that a little bit bigger though, because I don't think it's quite big enough. So hopefully you can guess what's going to happen here. So I'm going to copy these around, make a few of them. They might look a little bit ugly, but that's okay. And same deal, copy all of them, copy paste, select all of them, copy paste, there we go. And I'll do the same thing. I'll make another parent game object for them. Move it to the middle of them, and I'll call this dirt top. How's the pacing of this for everyone? Is this a little bit too slow, or is this okay? Or maybe even too fast. I haven't got into the tasty code stuff yet. Chuck your comments in and I'll address them when they come up. Cool. So we have our dirt top. We can look into the game and we can see what that looks like. Oh no, it has a horrible outline. Ooh. Let's see if we can solve that. Okay, so let's look here. Do we see anything funny here? No. I have an idea of what it could be. So let's jump back here. And I think probably this is quite a very particular kind of game bug. And it could be, if we go to our sprite editor, it's such a silly game thing. So in here we have this transparency happening. The way I saved the file in Photoshop actually meant that instead of taking on this color, it's just blending into white. So even though it's transparent, so say this pixel, for example, maybe here, right? Very transparent. It's actually also a blend between this color and white. And that could be why I've got these white edges occurring. So the easiest workaround, it's a little bit of a hack, but the easiest one is just to actually trim this down. So just make sure that I'm chopping it off at the edges. Like that. Oh great, if you have no outline, fantastic. It might just be something funny on my computer. And that's one of the joys of game development. Great, so now we can see that it seems to look a bit better, so that's nice. I'm gonna go back to my scene view. So I mean, you might, if you end up like, why can't I click on anything? It's not working. You might be in game view, which is what I just did then. So go back to scene view, and then I can align them all a little bit nicer. And if you want to be really particular about it, there are ways of snapping it, but I'm not going to worry about it for this little mini lesson thing. Great, so we have the dirt top and the dirt. So what do we want to do now? Well, let's have a look at the game. I hate this background color. I'm going to change it. So you do that on the main camera. The camera is how the game visuals are all being figured out and being made. So it controls the background of itself. So we can just change it here. I'm going to make it a little bit of like a nicer kind of sky blue. It's probably not the best color because I'm not the best at colors generally, but let's go with something a little bit green actually. It's kind of cool. All right, great. So we have this happening. Now what do we want to do? Now we want to actually plant seeds. So there's a few ways we could do it, and I'm really open to suggestions. So if people are like, oh, I want to make the design work this way, by all means, chuck that in the chat. I would love to hear what you want to do. But I'll just go ahead with something while I'm waiting for any thoughts anyway. So we've kind of got this little dirt mound thing. Sorry, this dirt hole, and then we've got this dirt mound. So there's two things we could, if we want to, we could go straight to putting the seed in there. So this is me thinking through the process of how I could do this. So say my end game design is to actually have it so the player maybe clicks on a bit of dirt and then, or maybe selects the shovel, clicks on a bit of dirt, it makes a little hole in the ground in this shape. And then they click on the seed, then they click on the hole with the seed or drag the hole into the seed, and then it becomes a little mound, and then the flower grows, or the plant grows. If that was my end design, I could try to work that all the way through, starting at the beginning. So the first thing the player has to be able to do is select the shovel and be able to use the shovel on the ground. That could be the first way, like prototyping I start doing. Or I could kind of jump a few steps and go, well, what's the most important part of the game? And it's the fact that the plant grows. So let's start with being able to maybe just click a patch of ground and have the dirt appear. Like that could be the first way I do it. And that's kind of like the seed already planted in the ground. And then to kind of check how other things work. So there's a few ways it could be approached. I think for this one, I might start actually by making the shovel and the watering can selectable. So I'm going to put them in this like little fake. I see I did it again. I was in the game. I tried to drag it in. Scene. Okay. I'm going to try making little selectable shovel and watering cans, because I think that would just be a little bit fun to have them follow the mouse. And then we can actually start testing our game. I think it's quite a quicker way of demonstrating some stuff. Okay, so it looks really terrible, but this is going to be our UI just for this lesson. So if I want to start clicking on something, and this is the core of most programming problems, we have to kind of work out, we have to break down what we want to have happen. So before I talked about what the player would be doing, so they would be, for example, clicking and selecting something, and then they could click on something else with that object selected, and then something would happen. So there's kind of that design flow. What's our game mechanics, and how do those function? When we start programming, we have to dig even deeper. We have to keep going into what does it mean to click on something, which seems like a bizarre question because as humans we're like, well, obviously you click on it, right? But the steps of that from the human perspective, if you've never seen a computer before, you've never held a mouse, what do? You've got to move the mouse cursor over the top of something, and then you have to press this button on it. So then how does the computer interpret that information? So the computer knows where the mouse is because of the position our mouse hardware is telling it, and that's handled through the operating system. So Windows knows where the mouse is, right? Windows is doing all that stuff with the actual hardware of the physical mouse. So our game knows from Windows, or if you're using a Mac, of course, it'd be the Mac OS, or Linux if you're using that, any operating system. The game knows from it where the mouse is, so it has a position for the mouse, and it can also get whether the mouse is being clicked. So let's just try, if we click, we select the shovel. So let's start by making a new game object. I'm going to call this one the game manager. We might change this later because I'm just doing this on the fly. It's kind of the fun of one of these little streams. And we'll make a new script on it. So we saw before that our camera has this special thing on it. The dirt, if we go into the dirt objects, the dirts have this sprite thing on them. And everything always has a transform. So this game manager has a transform. We don't care about its transform. It can live in Narnia. Actually, I used to call my game managers Narnia because it doesn't matter where they are. They exist somewhere else and it's not important. They're never going to be visible to the player. They're just this little thing that contains information for us to use as game developers and as programmers. So where these things have sprite renderers, I'm going to give the game manager a script. So let's make a new script and I'm going to call it maybe object tool select. So in a bigger game like Space Princess or some of the other projects I've worked on, you have a game manager that might handle things like level loading and scene management and like overall score, lives, all that kind of stuff. Anything that doesn't really exist per object is best stored on some kind of special object that you know as a developer and your team knows is like the special object that manages the high-level holistic stuff. So let's go to Tool Select. So we'll double-click on this, and this will open up Visual Studio. If you are using an older version of Unity on a Mac, it will probably open up... let's see if that works. It'll probably open up MonoDevelop, which is totally fine to use as well. I prefer Visual Studio personally, but that's just my personal take. And Visual Studio is maybe a little bit richer because it's used for quite a lot of development. But then there's a lot of programmers who hate it too. So, opinions. That's a really important thing as well, is that like when you get into the programming world, especially if you're new to it and you're not sure if what you're doing is right, there are lots of opinions and there are lots of people with differing ideas of what's right and what's correct. And at the end of the day, it's about if it works for you and if it works for what you're making. So if you find yourself coming up against a challenge and there's some bug and you can't fix it and you can't figure out why, or some feature you want to add and you don't know what to do with it or how to make it happen in this particular engine you're using, then it's time to kind of think about how you're approaching the problem and if there's a different way of solving it. But if that's not the case and someone's just like, oh, you just use JavaScript, ha ha ha, like who cares, whatever, they're on a high horse, let's not worry about them. Oh, this version of Visual Studio is light color. Oh, there we go. Great. You can see my horror that it was a light colors game. I'm very particular. Okay, cool. So here's our Unity stuff. So we double clicked on this and that opens up Visual Studio. So it's going to take a little while. And what it will do is give you this pre-made code. So every script you make in Unity will always come with this pre-made code here. I'm not going to talk about what these things are today. I will note that this tool select, so whatever word is here, but like after public class tool select, monobehavior, this word here must match the name of the file. That's just a Unity rule. And it's quite common in a lot of code languages. They have to match, but they don't technically, it's not technically required in some other languages. But for Unity it is. So if I change this and saved it and then went back to Unity, it'll be like, oh my goodness, where's it gone? Or maybe it just won't do anything until I change the program properly. In any case, you want to keep this exactly as Unity names it. Okay, it also shows us these two weird, like, oh my goodness, if you haven't programmed it, be like, what is going on here? We've got some slashes and this has gone green and then that's blue and there's these more brackets. There's brackets everywhere. What's happening? Yes, and yeah, Doom Bunnies. I definitely suggest Visual Studio if you don't get overwhelmed by it. I think the main thing is that it's got lots of stuff happening in it everywhere, and like there's all these weird buttons. And even though I've used it for quite a long time, half the time I'm like, how do I get to the tool, like the package manager, and I just can't figure out how to get there, and it can be a little bit overwhelming. It's a bit like when you start using Maya or something like this. But if you just stick to like just changing the code and saving it, it's usually really good. And the reason, even though it has more features, you might want to use it, which I'll show you in a little while, is that you can put in line breaks and it auto fills. So if you start typing, it will continue for you. Okay, great. So what do we have in here? Right, tool select. So it has to be the name of whatever we're doing, so that we can go, okay, all right, tool select is the name of what we're doing. Mono behavior, this one's a bit strange. I don't know what that is. I'll talk about what all these words mean in a later lesson, I think. They're all really important and they're all really exciting to learn, in my humble opinion. But when you're starting off, it's just like, oh my goodness, what's happening? I don't know. So don't worry about them at all. These things here, these double slashes, are used for comments. So this is human writing. This is a human being like, here's the purpose of this thing. So when you start writing programming, and I'll do this a little bit later on, you can start by writing out what you want to have happen. So you might be like, oh, I want to have it, so in the case of our tool select, when the mouse is pressed down, check if it is over the shovel. If it is, select the shovel. So you can type little bits of code like this. I find this really helpful, especially if I have a big like more challenging code or slightly things that need to be really efficient and I'm not quite sure how to approach the problem. I just write it down in comments. And if you're looking at other people's code, hopefully they've commented it. Some programmers don't, and you're seeing this big jumble of programming that you can, if you know it well enough, you can sit there and digest it. But it's much easier if you have comments telling you what each section of the code is doing. And I'm not going to lie, if you personally work on some code and you don't comment it, and then 2 months later you come back to it, you're probably going to have a little bit of a struggle understanding what's going on. Okay, so that's what comments are. That's what these things are. Now these ones, these are really important. These are called methods, or sometimes they're called functions. And they come as a kind of a whole. So they have this whole little setup you'll see here. And there's a whole set of them that we can use in Unity, not just the ones that are in this bit of code here. So let's do something really basic to begin with, and then I'll show you some more functions we can look at. So I think we can use the print function. I don't usually use the print function. I often use a function called debug log, but they do the same thing. So I'll say print start with exclamation mark, and I'll put a semicolon at the end. If we're programming in C#, we need to have this semicolon, and most programming languages need that as well. So I won't talk about exactly what's going on here, but this is a string, so I've had to put it in quote marks. A string means it's a set of characters, and that's why it's called a string. It's a string of characters or a string of letters. That's why we call string strings. And print is this method. So there's a method here called start that we're writing, and this method goes somewhere back into the computer, into Unity's system, and it goes, excuse me, can you please print this word that somebody sent me? And the computer goes, okay, I'll do that for you, and it prints it somewhere. So I'll put print there, and I'm just going to copy paste into update, and I'm going to write update in here. So we'll just see what that does. So I'm going to save it. So Control S to save, or file save. This is how often I actually file save. I guess, yeah, save that one again. And then I'm going to tab back to the game. And we'll see that because I have this selected, it actually updated the code in here. So I can immediately see the code in here if I want to. I very rarely look at an assets code in the inspector, but you can do that. And now it looks like there was no compile errors. It's pretty happy. So if there is a compile error, there'll be a little pause when you tab back to Unity where it's like thinking and it's compiling. And what that means is it takes all of this and it turns it into machine code. It turns it into something the computer understands rather than it being kind of human letters that we understand. So it was fine compiling it. So what I'll do is I'll hit play and we'll just see what happens. It's the first time we've done this. So hitting play begins our game. You'll see it has moved us into the game tab automatically. So if I stop it again, we go back to the scene tab. If I hit play, it moves us to the game tab. And now the game is actually playing. So it's different to the way we were looking at the scene before. It's looking at the game tab before where it was kind of a paused view before the game ever starts. Now it's actually as though the game has started. And hopefully we can also see there's a whole lot of these numbers counting up here. And there's all this stuff that's appeared in the console. So not only did it switch us to the game tab, it also switched us from the project to the console. So in the console, it's printing update. And it's also giving us a time, which is really nice. So it's telling us when it happened. And we can see it just keeps doing it. If I go all the way to the top, there's start. So start and update. So now we know, in terms of the computer, when these things happen. So start happens, as you might expect, right at the beginning. An update happens, apparently all the time, it seems. So you can even count, because it's got the time on it, you can even count 21, woof, up to here. That's a lot. That's like maybe 40 of them a second, 30 of them a second. Okay. I can help you out with that, Kate, later, if you like. It's a little bit of a pain that Visual Studio does that. Okay, where are we? Great, so now we know what those things do. Okay. Now there's a whole lot more that we can actually do than just start and update. So if we want to see them, we can go to the Unity documentation. I'm just going to open that up on the window. And anyone who acts like they program without a reference open is probably a liar. So when I'm working on anything, I'm constantly Googling, I'm constantly looking in the user manual, I'm constantly reading books about stuff. Like, you've got to be engaging with new ways of doing things rather than just remembering it from memory. That's pretty impossible. So the Unity manual is a really good place to go. And actually what we're going to go to is not just the manual, but the scripting API. It's this one here. If you're new to programming, this should be, it's basically your Bible. This is your home. This is where you need to live. So we want to look at Unity Engine. The editor is something, it's actually if you want to make changes to the editor itself, so the editor being this application, which you can do in a kind of limited way, which is actually quite useful, and I use that a lot in my work. But we want to look at the Unity Engine. So there's lots of things in here where it's like, what are you talking about? What are these things? Serialization, spatial tracking, social platforms. Ooh, sprites. We know that one. So you can look for things you reckon. You can either look through it this way, but more than likely you're going to be like, well, tell me about something. So you might be in your code, you might be like, tell me about update. What is update? So we would go back to, go to our, I have too many windows open, API, and we would search for update, just in here. So searching script reference, please wait. It's got all these different things that come up, heaps of things. So we could look at the very first one, see what that is that right? Unity Engine Experimental Player Loop. We don't know what those things are. Native Player Loop, no idea, seems weird. Experimental, this API might be moved or changed. This seems like the wrong place. So this will happen, you'll be like, I think that's what I want. And then it's like, oh, this is not right, something's weird. And that's fine. Now, there is something somewhere in here we do recognize from earlier before. It's the word mono-develop. Sorry, mono behavior. So go into the mono behavior update. And this looks a bit more like it. So we have this void update. This is what we were doing before. And it tells us update is called every frame if the mono behavior is enabled. So what that translates to is it's saying that update will be called. This text in here will be called. So let's play this game again. It will be called, and you can see that it's ticking up consistently, unless the mono behavior is disabled. So if I uncheck this here and turn off that component, it stopped. The code has stopped ticking, just like that. So it has lots of little tips about how things work, so you can read through it and it tells us about stuff. It's most commonly used to implement any kind of game script. Not every mono behavior needs an update. So that's telling us, it's a little hint to say, if we don't want to have these, we actually don't need them, and Unity is fine with that. But I want to find more. This is telling us a little bit about what we can kind of see already, but I actually want to know more. So it's telling us about mono behavior. So that's that, again, that word we saw here, mono behavior. So you can imagine all of your scripts are a type of mono behavior. And in later lessons, I'll talk about child and parent classes. But for now, just know that every script you make has to be a mono behavior, and it will usually have that word on it. Will always have that word on it. And that enables it to do anything a mono behavior can do. So we can click on mono behavior and see a bunch of cool stuff that a mono behavior can do. And in here, we'll find things like the one we just used, like update and start. So both update and start are in this list. And that means we can do anything else that's in here. We can override it. So you can treat these as though they're events. So something happens in the game, like the game starts or the update occurs, which is like a thing that happens multiple times every frame. On mouse down, on mouse drag, all this stuff. All these events can occur on trigger exit, on trigger enter, if you want to make a kind of collision-based thing. So I'll zoom this in for you. And you can look at what all these things do. Like, what's onValidate do? When the script is loaded or its value changed in the inspector, you're like, oh, okay, cool. That's a bit like we don't need that for our game, but maybe one day in the future that would be cool to do something with. Okay, cool. So there's lots of things we can do in here. Even things like on destroy. You know, if you have a game that has bullets that get destroyed and you want to make sure that you play an animation when they get destroyed, you could put something in the on destroy. So let's test awake, because that's a really nice straightforward one. So I'll type a new one. I'm going to follow the exact same pattern as the other ones. So if you're ever not sure, you just follow the same pattern. So void. Oh, look at that. Just auto-filled it. It's a nice thing about Visual Studio. And I actually put the word private there, which you don't need to worry about. You can leave it there or you can remove it. It doesn't make a difference as far as Unity is concerned at this stage. And I'll put the same thing in here. I'll just put in print awake. And then we'll test this, and then we'll actually start doing stuff, because I want to start doing stuff, and it's already been an hour, which is crazy. Okay, so we'll stop it. And you can see I have this habit. I try to click clear, because if you click clear when it's still compiling, it doesn't do anything. But if you click clear when it has compiled, it does work. So we know it's compiled and it's happy. And I'll show you what a compile error looks like very quickly, actually. If I just put some random letters here, or if I'm missing a bracket, for example. There you go, it has some error. There's a whole other topic in there on error, on like working out your errors. So I won't go into that now, but that's something I could cover in the future if you like. Okay, cool. So we hit start and let's see what happens. Go right to the top. So awake happens first, then start, then update. Cool. So we can start to put these little prints in to see when things occur. And there's also a really cool way of doing this, which I'll show you again. So for now, I'm actually going to delete both of these, and I'm just going to look in the update. So let's look at what we want to have happen. So when the mouse is pressed down, check if it is over the shovel. If it is, select the shovel. So we need to work out what select means. Select. What is that? But let's work on the first two to begin with. Okay, when the mouse is pressed down. So how do we tell if the mouse is down? There's things so you can do something as simple as simply Googling Unity mouse down, and you can see what comes up. And it has a few things. So let's have a look at this one. Input get mouse button down. input.get mouse button down. Returns true during the frame the user press what? The user press the given mouse button. Beautiful. So frame, that's an interesting word. Something I didn't mention is that update is called every frame. So that's why update kept appearing. The faster the computer is, or the more optimal your game is, the higher the frame rate and the more update is called. The lower, if it's a lagging computer, update's called a little bit less. But the idea is it's always called every frame. So before the player gets a new set of visuals, the update function will be called. So this is where most of the juicy parts of your game will happen. So where you're going to put all the cool little checks in to say, like, have things collided, or is something, has a mouse button gone down, or has the color, like should the color change, all those different things will be done in the update function. Anything that relates to time usually will be done in that. So we can look at their code and we can actually just copy a chunk of it. So let's just copy that and put that into our own one. And I'm going to comment out this code. I might use it again in the future, but I'm going to leave it commented. This means the computer will now ignore it, pretends it doesn't exist, just like it does with our human text up here. I'm going to save it, jump back to Unity. Oops, too far. Unity, and let's see what happens. Did anything happen? No? Let's click the mouse button. Oh, there we go. Press primary button. Great. So every time I click, which unfortunately you can't see very well, every time I click, this increases. Beautiful. Also, you'll notice that the game looks like my icons have disappeared. So you can have a look at why that is as well. Might be because my aspect ratio changed. So I'll just move them back on over there. Okay, cool. Now what do? We want to do the next part. So now we know if a mouse is pressed. We have this new thing with an if here. It's called an if statement. So, I'll dig into that a little bit later. For now, we can just know that if this thing in the middle is true, so if it's true that the mouse is pressed down, and the 0 is the left mouse button, if I change it to 1, that's the right mouse button. And again, this is something where, like, I only know this because I've coded for a while, but when you're learning, it's for sure normal to not know what the heck is going on. And you have to look in, again, the API. Tell me, API, what's happening? And have they commented their code? And it's good, they have. Great, so it tells you the button values are 0, 1, and 2 for the middle. So I'll leave it as 1, as the first mouse button for now. And it's logging something, so it's giving us a little bit of feedback. Now we need to know if it's happening over the shovel. So how can we do that? We need to somehow have a way of knowing where the shovel is. So if I click here, we only want that text to appear if it's over the top of the shovel. So there's two things we need for this to happen. And again, this is like a per engine thing. Different engines work in different ways. But generally speaking, game engines will have colliders and they'll have raycasts. There are other ways of doing this in Unity, but I'm going to do this this way because it's kind of the more robust way. So I'm going to search for 2D Raycast. And again, if this is something where you're like, how do I do this? Oh my goodness, how do I know these magic words? That's fine. You can just Google. You can Google mouse over 2D sprite Unity. So you kind of have those keywords. You're doing a mouse, 2D sprite, and it kind of tells us how to detect a mouse click, and Unity answers. And people have different solutions to the problem. There's not one way of doing it. So there is the on mouse over and on mouse down functions as well, which you can use. But I'm actually going to not use those because I had some bugs with them last time. So I'm going to use that's why I'm using this for a more robust way. So let's have a look at Raycast hit 2D, or maybe Collider Raycast. Let's look at Collider 2D Raycast. So does this have an example code? No example code? Nah, let's go find something that's easier to understand. Oh no, Unity's not working. Okay, maybe... No? Physics 2D Raycast? Oh, it's all gone down. Now this is where if you've installed the API, it's really helpful. So you can when you install Unity, you can check a box to say documentation. If you did that, then you can actually load it up locally. So you see this now as my local files rather than being the internet. And at the same time, if you can't get to something, you can also Google it, and people will have code snippets in like Unity Answers and Stack Overflow and places like that. How are we all going? Do a little health check. We all following? Is it a bit slow, a bit fast? Should we go for another half an hour to an hour, get some plants actually doing some stuff? Would you prefer it if I kind of just sped up and did things and then posted the code, or kept on going through in this nice kind of detailed way? Let me know in the chat. Okay, so here's the user manual. So same thing as before, it's just this is a local one. And again, I'll search. This time I'm going to look for, maybe let's do 2D Collider. No, Collider 2D, sorry. And to kind of know what to search for, because I knew that from memory already, what I might do is, if we suppose our shovel should be able to be clicked on, then we know it needs to somehow have this physicality in the virtual world. So while it has a sprite renderer to make it visible, so even in 3D you'll have a mesh renderer or a different type of renderer to make it visible to the camera. In this case, we have we want to add a collider. So colliders in physics make things physical in a way. So one part of games is that we try to make the illusion of something feeling very real or feeling very similar to reality, whereas in the actual back end, it's quite different. The way things are working is not, it's trying to simulate reality rather than actually truly be reality. Obviously, otherwise we'd just be playing the game of life, which is a very different kind of game. So if we want to have things that are visual, we put renderers on them. If we want things to be physical in the virtual sense, then we add a collider to them, and we also add a rigid body if we want them to be. So to give you an example of that, I'll put a polygon collider on this actually, just for this one section. So you can see as I add the polygon collider to it, it's actually mapped it to a nice little shape. And just for the sake of showing you something cool, I'm going to add a rigid body to it. So this tells it that it should exist in the physics. So not just that it should have a shape and a form in the physics system, but also that it should actually be physical and it should do stuff with physics. And now if I hit play, we can see, let's just play that again, that it just falls right off the screen. And if I did the same thing to the dirt down here, so even I could select all of the dirt and add a box collider to them, so you can see they all now have little boxes over them. If I hit play, now falls and hits that box. So if you want to add some physicality, you can do that quite easily. Okay, great. Thank you for your comments. So if you did want to make a physics game, and this is what I was saying earlier, that kind of shooting and physical and twitched kind of games are more commonly made, and therefore engines are more focused around them. This is kind of why we're doing, to make a click on, it seems like to make a click check, it seems like a lot of work, whereas to make something physical, it's very easy. And that's kind of just a symptom of the type of games that are most commonly made. But again, different engines have different features. If you made something in Rempy or Twine, it has no physicality at all, because those engines are completely about dialogue and text and narrative. Okay, so I just wanted to quickly show you that as an example. And I'm just going to remove those components again now. Just the rigid body from the shovel, and then from the dirt, I can select them all again and just remove that box collider. We're not really going to have any physicality in this, but if you want to go ahead and add that in yourself, you're welcome to. That could be quite fun. Okay, so I have this polygon collider, and actually I'm going to remove that too. I'm going to change it to a box collider. And the reason for that is that people don't want to have to click precisely on it. They just want to click in roughly the right area. So I'll make that box collider maybe even a little bit bigger. So I'll scale it up here. So all these options in here, just like we can change the position with these numbers, all the things inside these components, that's what these things are called, components that we've added to the game object, will allow us to change aspects of it. So I'll leave it like that. And this script that I wrote that says tool select, I'm actually going to move that. I'm going to move it off the game manager and onto the shovel, because looking at what we wrote, It says when the mouse is pressed down, check if it's over the shovel. If it is, then select the shovel. Well, that seems very specific to the shovel. I think it's not really a holistic, high-level bit of code. It's very specific to the shovel, and we might do some more complicated things with it later. But for now, I think it's probably better if we move it to the shovel. So I can just drag it on like that. It's a new feature, I think, in more recent Unity. It's pretty cool. If you didn't want to drag it, you can also right-click it and copy the component, and then you can paste it. Paste it as a new component like that. Cool, so now my tool select is on my shovel. So it can kind of reference itself now, so it knows a little bit about the object that it's on, and we'll dig into that. So let's go to this Unity2D thing. Now this is the real juicy part of programming in Unity that I quite like, or programming with a component system. So I mentioned that word earlier. These things are called components. So the transform component, the sprite renderer component, the box collided 2D component, and even the script itself is a type of component. Sorry, pardon me. Ollie the dog has once again sat on my audio cable. Come on, buddy. What you doing? Oh, come here. Oh, you want belly rubs? Oh my goodness, come on. Oh, buddy, come here. There we go. If you didn't see him earlier in the ready to stream, he's a little weird palm cross thing. And he's now sitting on my lap and licking my wrists. That's very nice. Okay, great. Where was I? Tool selectors here, components. Yep, beautiful. Okay, so what's really cool about Unity is, so we have these numbers, right, that we can change. Everything in here, all these numbers of all these components, we can change them in code. And it's actually really straightforward as to how to access them. So say you want to have the shovel change in scale a little bit as the game plays. You just have to get access to the transform, and then you need to change the scale of it. So I'll do a really quick example of that, and then we'll do something more interesting with the collider. So let's say during the update, we want to make the transform scale larger. So as I start typing using Visual Studio, it's already auto-filled to this thing called transform, and it says the transform attached to this game object. Hopefully you can read that, it's not too small. The little tooltip here. So these tooltips are really, really useful, and usually if you haven't got the API open, the only time, not the only time, but one of the times you'll open it is if there's not enough information in the tooltip. Once you've got your basic feelers around using Unity, you can kind of use this just to work out what stuff does, and then if you have more complicated stuff, you can look at the API and search it up. Okay, so transform, and now we're going to use this dot. What does this dot do? What is going on? What is going on with code generally? Like, why are there semicolons? What are all these brackets? Okay, there's too many things to answer there. But I can tell you to treat dots as though they're an apostrophe S. So imagine dot is an apostrophe S. So if I say transform dot, let's change the position as an example actually. Position plus equals, don't worry exactly. Yeah, let's do plus equals. I'll do a few things here. I'll do a few things, then I'll explain what I'm doing, and then we can kind of step back into some other stuff, just because this is like a basic little introduction to component stuff. So public, okay, so there's a few things I'm doing. All right, so public vector, this is often your brain starts working in this way, where you kind of like, you're like simultaneously like, oh, I want to add a new thing in here, but to do that I have to add a thing up here as well. So there's a few concepts I'm gonna do at once. So I'm making this new thing, public vector3 speed. Now, the more you learn to program, if you've programmed before, you don't actually need to use public. What you can use instead is this thing called serialized field. This thing here. From a beginner perspective, they seem pretty much the same. But where public is a accessor, so other bits of code can now access this. Oh, great. Thanks. Serialized field is a specific kind of special Unity thing to say that actually make this field open in the inspector. So I'll show you what that looks like. But public does the same thing as it. So if you see either of those kind of and you're beginning to program and you don't quite know what they are, that's fine. Treat them as though they're almost the same thing because they are quite similar on the surface. Okay, so public vector3 speed. Vector 3 is basically like a number with 3 different numbers, or like 3 numbers all packaged into one. So it's often used for positions in 3D space, or scale, or rotation, although rotation has a different, more advanced version called quaternonian. It's a type of thing. But vector 3 is just 3 numbers, basically. You can imagine vector 2 has 2 numbers. So transform position plus equals, and actually I'll write this in a simpler way as well. I'm going to say equals speed plus transform position. Okay, so there's a few things going on. I'm going to demonstrate it to you first, and then I'm going to explain what it is. So this is compiling. You can see it was just thinking for a bit, and now my tool select has these numbers exposed in it. So I'm going to set this to 1, just the x value to the number 1, and like we could before, we can drag this around. There's nothing visible that's going to show us what that means, because if you want to do that with your own scripts, you have to code up the visuals, which is a whole extra set of work. So for the most part, you will kind of know what this thing will do, and if you expose something like this, and then you'll see what happens. So let's hit play. So I've set the speed to 1. Let's hit play and let's see what happens. Whoa! Let's play that again. See what happens? What? There it goes. Okay, so let's do that again a bit slower. So let's set this to 0.1. There it goes. Hey, see you later. So this is different to the physics one we had before. The rigid body we had was simulating physics on the object. This time, we're actually, you could imagine every frame, we're teleporting it a little bit. So you can relate this stuff we wrote up here directly to these numbers here. So these are exactly the same. These are the same thing. So they're quite straightforward to understand. Well, they're not straightforward, but they kind of relate directly to one another. This is a little bit more complicated. So the first thing is here, transform is getting the transform component. We're accessing with that apostrophe S, so transforms position, which we know is this number up here, this position number here, which we can change. And then we're putting this equals here, and we're saying speed, so the number that we put into it, plus the number that it already is. So you can kind of work out the maths on that. So if we know that, or maths on the second half, I should say. So if we went here and we said, okay, what's the maths of this actually? So the speed is currently 0.1 on the x. Let's talk about the x-axis only. And the current transform position is at, if we move back to where it was, this bizarre 8.5 something. Oh, thank you for auto moving that. I want to keep it there. 8.1. Okay, so 0.1 plus negative 8 point something, so that equals some number that would be roughly negative 8.47. Is that right? Yeah. Yep. Roughly that. So you wouldn't normally do this. Once you kind of have the basics of code, you wouldn't do this calculations, but it can really help when you start to learn to program, to really think about what these weird words represent. So in this case, this speed word represents this vector. We know the vector is 1 because we set that up in the editor, in that little component section. And then we're adding to it, we're saying take the position that we already know about, which is this one. So that's in the first, at least in the first frame, right? And then this little equals is saying, okay, take everything on the right side and put it into the left side. So every time you see an equals, always remember it's taking the stuff on the right side of it and it's putting it into the left side. It's always going to be putting it into the left side. And it doesn't matter, it computes this first. So imagine that this is like a brackets, there's a brackets around here. It always thinks about what's happening here first, and then it puts it on the left side. So you'll very, very rarely see I don't think I've ever seen in my life anything like this. And in fact, it's given me a squiggly line. It's like, what are you doing? That doesn't make sense. And that's because this equals is expecting there to only be one thing on the left, and that's the thing that you're saving all the stuff on the right into. So I'm probably like repeating myself a lot, but it's a really core concept that I want you all to understand. Okay, cool. So transform position equals speed.transform position. Great. So what this is doing then is every frame it adds 0.1 to wherever the position was. Now we can actually test that by pausing the game before we start it. So this is pause button, which you might have seen before. We'll hit play. So nothing's going to happen because we're in the first frame and our code actually hasn't run yet. if we hit this one here, this is the step frame button. So if we click that, sorry, it moves it one, you can see it moving it one little bit at a time. And you can even see the numbers in here, and you can see those numbers. Yep, that's what it's doing. Plus 1. So 7.77, 7.6, or negative 7.6, negative 7.5, etc. Now, if you are going to do any transform movement stuff, there's one tip I'm going to give you, even though that's not really what this lesson is about, this movement stuff, but it's, I think, quite an important one. And it's that when you have a speed, don't just have the speed as it is. Speed by itself, because we know, we talked about it earlier, the update is based on the frame rate. On a fast computer, that means, so if my computer is really efficient, that means this will move much faster. On a slow computer, it'll move much slower. And that's really bad. That means that different players will have different experiences of your game. I've heard this problem happening a lot with different developers, kind of new developers who weren't aware of it. So all you have to do to solve that is to instead multiply this by this thing called time.delta time. What is that? What is going on? That's something you can look up in Unity, but if we hover over it, again, we get a tooltip. It just says the time in seconds it took to complete the last frame, and then in brackets read only. The time in seconds it took to complete the last frame. So what that means is how long was between the frame? Maybe it was 10 milliseconds, maybe it was, if it was a slow computer, maybe it was half a second. If it was really slow, maybe it's a whole second. So that'd be a frame rate of 1. That would be terrible. But we're multiplying time by it, multiplying our speed by this number that is the time between frames to make it standardized, to make it a normal, to make it the same for each different computer, no matter how fast or slow the computer is. So even if your frame rate is at 20 or 30 or 100, it'll still be the same. And what you'll notice doing that from our perspective right now is that now it's really, really slow. And this is the second benefit, is that now this number isn't just like a random number that we hope matches. This number now represents 1 unit. So 1 unit per second is what that now represents. And that's the speed that it's currently traveling. Okay, so I'm going to comment this code out. You can have a look at that if you like. And the alternative version, when I post that code up, that is. And the alternative version, which is a similar thing, is this plus equals speed times time delta time. These two lines say exactly the same thing. The plus equals just adds in this at the end for you. It's a shorthand. There's a lot of these in code, and I think we don't explain them, like programmers don't really explain them very well, and it makes it quite difficult for beginners to understand what's going on in advanced code because of that. So that's my little cheat sheet thing, is just that this plus equals is imagined that it's got the plus transform on the end, or the plus of whatever it is at the beginning. Whatever this is, it just adds it on the end. Cool. Okay, let's actually get some plant stuff going. Oh my goodness. It's been so long and we still haven't made a plant do things. Okay, so we have this collider. We talked about the collider. So what we're going to do now is see if we can find this stuff about raycasting. So doesn't look like it's in here. Let's search raycast. This will tie back into collider in a second. There we go. This is the one that didn't have any information, isn't it? And this is totally normal to like just be searching for stuff and to not, well, at least I tell myself it is anyway. Oh, it still hasn't got any information. That's so strange. Okay. Well, let's do this one instead. No. Physics raycast. Oh, there we go. Okay, great. This is what we're looking for. Now, really important note, if you're making a game, especially if it's a 2D game, be aware that the physics system for 2D and 3D are different. We're making a 2D game. We're using a box collider 2D here. So that means everything has to be done through the 2D system. This example here is in the 3D system, which I'm going to use, and then I'm going to change it to make it appropriate for the 2D system. It's very, very minor. So if we look at this code, we can work out a little bit of what's happening. It talks about bit shifting. Let's not even, don't worry about what bit shifting is. That's like a super advanced topic for later on. It's not super advanced, but it's something for much later on. And all it's really saying is figure out what layers you want to have hit. Often in games, you'll have multiple layers for the physics system. So for example, if I had lots of water in the game, and the water's all doing physical things, so they're all hitting the ground, I might not want water to hit water, because if water hits water, it becomes very expensive because all the raindrops are hitting each other. I won't give you a detailed example of that, but that's what this layer masking business is about. But what I want is just this little bit of this kind of logic that's happening here. So it has this thing called the raycast hit, and it's called it hit. Nice little bit of comment of code that says, does the raycast intersect any objects excluding the player layer? So it's talking about the stuff up here that we don't really care about. So there's a raycast intersect any objects, and then it has this little if, and then it has some brackets. So let's copy this whole chunk. I'll put that into our code in here, underneath our little detour about position. And I'm just going to add 2D on the end of these. Physics hit 2D, and you can see it recognizes it. And that's because I remember that most of the 2D stuff in Unity just has 2D at the end of it. So physics 2D looks happy. And then I'm going to get rid of their debug stuff because we're going to do our own logic in it. So what does it say? Does a raycast intersect any objects excluding the player layer? Okay. And I'm actually going to... So I just want this physics 2D raycast. That's what I care about. So I'm going to get rid of some of this other stuff in here. Now note when I do this, when I'm cutting things out, I'm being really careful to make sure the brackets match. And often engines will show you. So if you select one of them, you can see they're both a little bit blue. If I select this one, they'll all kind of go blue. If I select this one, it's gone blue. So you kind of know these things match up. Really, really common beginner mistake is just to not notice that you're missing a bracket or have an extra bracket even. And then that will cause all sorts of problems, and the computer isn't smart enough to know it's just a bracket missing. It's really simple to us as humans when we see it. We're like, oh, it was a bracket. But for computers, it's a really hard mistake for them to pick up on, so they're not very good at helping you solve that. Okay, so it's a bit upset because I do actually have to put information in here. Now, I won't go into detail on what this is, but when you put things inside the brackets, so every method, every kind of trigger or action that we're telling the computer to do is always inside these curly brackets, and inside these methods and whatnot, even this one debug log here with the brackets, or print as we had earlier, or even get mouse button down, these brackets. Inside here, it usually takes a thing called parameters. Parameters are like extra information. So in the case of get mouse button down, get mouse button down 0 is telling us which mouse button to get. So I can change it to 1, and that means the second mouse, the right mouse button, or 2 is the middle mouse button. 0 is telling us it's the primary one, the left one. Again here, it's taking a parameter. Debug log is telling it to print to the console in here, like we did earlier, but a different way of writing it. And it has to have things. If we just had this, the computer's like, okay, log what? What do you want me to log? I need more information. Tell me more. So the things in the brackets are us giving the computer extra information. And later on when you do a bit more programming, or maybe you already can, adding your own parameters to stuff and your own functions is really, really handy. It lets you make very modular, very reusable code. So in this case, our raycast function wants to have more information. It's like, what am I raycasting? So what is a raycast? If I have my camera on, I'll like point at the screen more. But basically a raycast is when you shoot. It shoots a beam somewhere. You can imagine it's just shooting a laser through the world somewhere, and it's telling you what that laser is hitting. So it's a single point that goes in a single direction. Now, in the case of this, sorry, I'm not sure why I have these notifications popping up. Okay. In the case of this one, let's see what raycast 2D. Let's see what it wants. So we can actually get that by retyping that bracket. It's a little bit of a hack. It's just if you have a function, you're like, what does the function need? You have that first bracket, and it tells you. And it has these little buttons you can click, or you can press the down arrow as well, the up and down arrow, and it will jump you through the different versions of it. So some functions might have only one thing they can do. They just take one parameter. Other functions might take multiple ones, depending on what it is. So this takes a vector2 origin and a vector2 direction. So we need to give it an origin. So where does the raycast begin? And then a direction. Where does it end? So we're going to do a little bit of a hack with this one. We're going to take the mouse position, so we can get that from the input. So just like same thing as we had up here, input.get mouse position. The input handles where our player and hardware input is. So mouse position. We need to convert this to world space. Now that I can't quite remember how to do, so I'm just going to quickly look it up. I think it's screen to world space or something like that. Camera screen to world point. Yep, that's probably the one. Might not be camera, we'll see what happens. So that's it there, cam.screen to world point. I think it might not be camera. So again, a case of like, just Google it. Okay, mouse, camera, world. Now the reason for this is that the mouse position, this thing, gives me back and tells us the current mouse position in pixel coordinates. But my world might have a moving camera or it might not have a moving camera. I don't know, and I could calibrate it specifically to this one camera in our game and it could be precise, but in this case, the best thing to do is to actually do this little conversion. So, oh, okay, with Monster Hunter, lovely. Okay. Mouse, camera, world. Let's just chuck Unity in there. Camera, screen to world point. Oh, it's just the same one again. Screen. Yeah, okay. Let's just do that then. So just have that separately. I'll put it down at the bottom to begin with and I'll copy it in. So camera, main. So that's our main camera in the game. Screen to world point. Is this one here? That's what we want. Screen to world point. And it takes a vector 3 position, transforms position from screen space into the world space. So it wants this. It wants the mouse position. So put that in there. And then we'll put this whole thing in here. And there's still one more parameter at once. And don't worry, this will be one of the most complicated lines we write by far. Vector 2 direction. So it wants to know just which direction to put it in. So normally you'd be casting a ray maybe up or down. So if you want something to stick to the floor, for example, like a car in a terrain game, you would put a ray cast pointing down from it into the pointing down from the middle of the, or maybe even the wheels of the vehicle. They'll point down into the world, and then they would find the point that the world intersects that line. In this case, we're actually going to hack it a little bit, and we're going to write vector 2, 0. And that's because our mouse is existing at one position, we can just check with that 0. So it's a little bit of a oddity one. That was one I learned from, I think it was Unity Answers or something. One time. And that's the weird little things that, you know, no matter how much you know about programming, you just don't realize that's even a thing until later on. Okay, great. So let's see what this does. Let's see if anything happens. So we'll put a debug log, and this is the same as writing a print, which is what we did before with the update. I'm going to say Raycast in here. And let's see what happens. Oops, do I have an error still? No, I don't. Okay, great. I do have a warning. It says hit is used, is declared but never used. Let's not worry about that. Okay, so I'm clicking, and that seems to be working. Oh, hello. Do you see what just happened then? Let's play that again. So I'm not clicking, I'm just hovering the mouse. As soon as I move it over that, it starts doing some stuff. So that's really good. So we can actually get a bit more out of this. So there's one way of stepping this whole thing back. So I'm cutting it out of the if statement. I'm going to put it equal, the hit equal to it. So if you hover over this function, so the raycast function, the first thing here tells us what this function returns to us. This is a little bit advanced, but if you're comfortable with like return types, this is really helpful to know. If not, then it's something we can cover more in the future. And so now I can say if, oh sorry, this is not quite right. Actually, I'm a liar. There's a different way of doing this. Out, hit. If I spelled it right. I did, okay. But I did it in the wrong brackets. Brackets, brackets, brackets. That shouldn't be there. Okay, and that's still unhappy. So again, let's look at that. Let's look at what that function is actually expecting. So origin int Actually, no, we'll do it the way I was doing before. Sorry, this is me kind of thinking through the process. What is the best way to do this? And also the best way to demonstrate it. Because it is quite an advanced kind of thing that's happening here. And it's quite unfortunate that it's required just to do a mouse over in this scenario. But it's still all good stuff to learn. There we go. So what this is now doing is doing the hit separately. So we do the hit first, and we save the results of whether that raycast, what happened with the raycast, into this variable called hit. So just like up here, we had a vector 3, which is a position. There's another one that's called a raycast 2D hit, and it has information all about what happened with the raycast that we just did. So we're saying if there was a hit, so you can also write this as if not does not equal null. There's a few things going on there. Those are the same things. So I'll just leave it as if hit. Oh, okay. Sorry, puppy moment. Okay, all good. If hit, debug, log the raycast. This should do the same thing that happened before, but this time we can get information from the hit. So I'm actually going to get rid of this as a string. So I'm getting rid of the quote marks. And hit dot, let's say collider dot name. So again, remember these dots are like apostrophes. So the hit's collider's name is a way of thinking about it, or the name of the collider of the hit. So let's play this and see what happens. So I'm mousing over. Oh, there we go. Cool. Oh, look at that. If we can see that, hopefully the screen isn't too fine. It's come up with the word shovel, which is pretty awesome. So if I hover over, it starts to increase. Hovering over, it's increasing a whole lot. As soon as I go off it, it stops increasing. Okay, so now we need to just combine these two things together. We have if we're clicking, and we're saying if we're actually hovering over something. How can we do that? There's two ways of doing it. One way would be to choose which is kind of the primary one. So for example, do we always do a raycast? And if we have a hit, do we then check what we hit and then change our behavior accordingly and check that the mouse is down? But probably the more straightforward way is actually to, I'll move this code down so it's out of the way of our earlier transform stuff. So if the mouse button is hit, instead of it just doing this one thing, which is you press the button, I'm actually going to delete that. I'm going to put curly brackets on it. Okay, so here's some curly brackets. Beautiful. So now, this will only ever happen if the mouse button is pressed down. Now these curly brackets are ways of chunking up your code. So you have certain actions and bits of things that you'll do, but you're going to chunk them up into these sections. And so we're now saying we're only going to do this big chunk of code if the mouse button is pressed down. So that's what these curly brackets are all about. And it's the same with the update function. This chunk of code, we only do that chunk of code when the update is triggered. And the same with all the other different functions we saw earlier. Okay, so let's see if that changes the behavior. Let's have a look. And while we're doing this, have a think about how you want to show that the shovel is selected. What do you think? Put your comments in. Awesome. Okay, so now nothing happens unless I actually click on this, and then it comes up with the word shovel, which is pretty great. I'm pretty much a fan of that. Got some strange puppy behavior. I might need to see what he's doing. I think he might be chewing some cables. Bear with me one moment. Oh dear, little puppy. What you doing, Ollie? Oh, you got my wombat. You chewing up my wombat. Oh, not a toy. I've got a stuffed toy wombat that usually lives on my desk, but for some reason it fell down. And looks like Ollie got it and decided it was a toy thing. But I'm glad he wasn't chewing up cables, so that's good. Okay, cool. So Gerard and Grey were not selected, but Doom Bunnies. Maybe give the sprite some sort of outline. Okay, cool. Both really good selections. selections. Both really good suggestions. I like that. Let's do... What could we do? Let's do it. Let's make it a little bit of a medium. Let's make it so it's transparent when it's not selected. So it's a little bit of a different one. Just because that's a little bit easier than some of the others. The other thing we could do is even have it follow the mouse around. So if you like that, we could we'll have it grow. Oh yeah, make it larger. That's a good one. Yeah, let's make it do that, because we've already done a little bit of transform stuff. So we'll make it a little bit larger when it's selected. Okay, cool. So how do we do that? So how do we make something larger? We did it a little bit before with the position. So now we want to change the scale. So we want to say if the button is down, if we've hit the target, then we debug log. So we know this is the point, this is where we hit it. So player has selected the shovel at this point. So now we need some more code to tell us that we've actually selected it. So I'm going to introduce a little bit of a new concept. So we've been using so far, we've been writing inside of update. Now we're actually going to make our own function. And that's just because this is getting a little bit complicated. There's a lot of, we've got a lot of tabs kind of going in to make this all happen. And this will actually clean up our code a bit. So, well, it'll clean it up as we continue to code. So I'm going to write void. So just like update, I'm just going to write one. I'm going to make up the words for it. So we'll make up the name for it. I'm going to say void select shovel. And there'll be nothing in the brackets, but I'll put them there. And then I'll make this. And you can see that it's gone. The red lines have disappeared. It's happy. It's like, okay, you can do that. And just like I call the other functions that are written by the Unity people, all I have to do is write the name of it, put the brackets on it, and then put the semicolon. Now this is just the way things are programmed normally from back in the old day, I suppose. And so most code languages follow this style of having these round brackets. So void, name of thing, round brackets, round brackets, curly brackets. And then if you want to call this function, you call it by putting curly brackets and then a semicolon. That's just kind of the way it is. But I'll maybe write a little bit of comments around the translation of this, because it can seem super weird when you start. You're like, what are they doing? Why is there a semicolon there? I don't quite know what. Like, how is that one different to that one? Why is there not like these brackets here? And the main thing is just to remember, this is probably the main thing, but actually a way of looking at it is as though this is a recipe, and this is you telling the computer to do the recipe. So imagine like a recipe for lasagna, and it tells you to make a white sauce or a bechamel. You have to write the recipe for how to make the white sauce, and then at some point in the main recipe for lasagna, you say, okay, now I make the bechamel, or now like add the bechamel to a thing. So that's kind of what this is like. It's a bit like a recipe. Awesome. So we select the shovel. So now this means instead of having to write all this information and a code in this weird spot that's all deep in here, we can just put our code in here. So it makes it a little bit cleaner. So what happens when the player selects a shovel? Okay, we want to make it grow, I think. Okay, that's a pretty good selection. So pretty good suggestion. So to change it, to make it grow, we have to change its scale. So transform dot position, not position, sorry, transform dot, if I try to write scale, it only comes up with local scale. That's because it's to make it really clear that you can't change, say for example in our dirts down here, if the parent scales, everything scales. So it's making it really clear that we're not changing the scale of it in world space, we're changing the scale of it just locally, which is nearly always fine. I've never heard a case of wanting to change scale absolutely. So when I say absolutely or world, what I mean is as though they're not inside a child object. And also for the case of the shovel, it's not a child of anything anyway, so it doesn't really matter. Okay, so we can do the same thing we did before up here with the speed. So I'll comment that out because we're not using that code anymore. But let's write a new one. So public vector3 scale. I'll call it selected scale. So try to be descriptive with your variables. Now I didn't really talk about this in detail before, but the first thing here you can kind of generally ignore. So I said about the serialized stuff, didn't I? Yeah. So if you want it to be visible to the user, so if you want to be visible inside here, you should write the word public or serialized field. Serialized field is like quote unquote the proper way of doing it, but public is totally fine as well. The second thing is the type of thing it is. So again, it's a vector 3 because it's the scale of it. And then the third thing is the name that you're giving it. So then if you want to reference that number that's saved in it, you access it through that word. So selected scale is not a bad name for it because that's what we want to describe, the scale of the object when it's selected. Just reading your comments. Which image select? Should it be private? That's a good question. So the correct way of doing this would be, again, quote unquote correct way, would be to write serialized field private vector 3. Now the difference is kind of subtle. So what it from the surface. So there's actually going to be no change. I have a compile error, so that won't work. That won't do anything with a compile error. If it's compiling and it's working, so we've changed that to selected scale, which is a different variable, the one we just wrote. If I change that now to public, there'll be no visible difference. But what that will change is whether other scripts can access it. So let's say we had another script that was like the plant grower or something, and it managed the plant, whether the plant growed or died in the sun. In that case, we don't need other scripts to ever have access to this variable. Only ever this class, only ever toolSelect needs to know what its scale is. Nothing else ever needs to know. So that's why private is the kind of correct way of doing things, because if it's public, then anything else can access it. And it seems a little bit silly when you're first learning, because you're like, why don't you just not access it then? But it's a way of enforcing correct behavior. And when you get more complicated code, it's really, really useful, because you start to kind of forget what things are private and what things are supposed to be public and which things should be exposed. And you kind of need to have the program like give you some rules. So you're kind of adding your own rules. Okay, so I'll leave it as serialized field private, so that when you see this code, you can get an example of that, as well as you have the public speed above, so to show that those are both similar things. Selected scale. Okay, great. So what we want to do now is say, okay, so if the shovel is selected, so this code is called here, then we're going to set the scale to the selected scale. Cool. So let's go to our code and let's actually make the selected scale all set to 1. Sorry, we'll set it to 2, so it doubles in scale. And let's see if it works. So one thing hopefully you've noticed is that you test regularly. Oh, it works. Look at that. Awesome. So click, it jumped and became large. Beautiful. Perfect even. Well, let's see if we can quickly apply this to the other ones. So the watering can and seed. I can take the same script, so tool select, and I can put it on here. So tool select on here and tool select on here. Now, if I wanted to change the default numbers, because these have all come up with 0, 0, 0, which means if we play it, actually, sorry, if I need to put a collider on those, so I'll put a collider on those. Box collider 2D. So those are a little bit smaller again, so we'll just make them a bit larger. The watering cans one has gone a bit weird. That's fine. Maybe 1.7. No, that's too big. 1.5, yeah. It's pretty much the same. Beautiful. If we wanted to make that this thing have a default number rather than it defaulting to 0, 0, 0, we could actually write in here equals. So just like we did before, where we had the equals for the speed. So we're taking the thing from the right and putting it in the left. We can actually give it a default value. So there's two ways you can create default vector values. One is you can write vector. So if it's a uniform value like this one, I could write vector 3.1. And what that means is I have a value of 1, 1, 1. So if I save this and say I'll just put it on a different object just to show you. Once it compiles, tool select. So that is now pre-filled with 1, 1, 1. If I want that to be 2, 2, 2, I can just multiply that by 2. So I'll save that and I'll just remove and reapply that same script. something quite important here that hopefully you've noticed. Okay, so now it says 222 on it. So if it's a uniform value like that, I can just type vector3 dot something. So in quite a global way, it's like vector3. So this idea of 3 numbers knows about the idea of 1, knows about the idea of having a value of 1. The other way of writing it is you write new vector3, and then you type in what numbers you want. And so again, this is a bit like not quite a function, but you can think of it like a function in that it's vector3, create a new one of these, so a new thing, and then you have these parameters in it that are the information it needs in order to create itself. So it needs to know what 3 numbers it should be. And that will, for example, if it wants to be 222, that will then pre-fill as we expect. So hopefully you noticed that when I change it in here, even though it changes it on a new version of that script, it doesn't change it on old versions. So new tool selects, I've just added on 222. Awesome, looks good. If we go back to the watering can, it's still 000. So be really careful that you don't accidentally think you're changing numbers here when actually they're already saved in the inspector in Unity. This is a really common mistake. Cool. Okay, so let's set them all to be, let's do 222 for each of them. 222. Sweet. And let's just see what happens. Yo, my. Anyone see what just happened there? Let's separate them a little bit, because it could be that we're clicking on all of them at once, maybe. So let's just make it really clear. Watering can, why are you a bit smaller? Oh, because I scaled it down, that's why. Silly. Okay. So I scaled down the actual scale, and that changed the collider scale, which is why the numbers, even though these are all 1.5 in the box collider scale, the watering cans is a little bit different because it had a different scale on the object itself, the transform. Okay, that's fine, that's good enough. All right, so let's try again. They're pretty clearly not overlapping now, so I'm just going to click on the seed. Uh-oh, still doing it. What are we missing? What's not quite right here? I'll let you think about that, and I'm going to do something else in the meantime when you can think about why they're all being selected at the same time. And why they're all being selected when I'm not clicking on them, which is a bit strange. So while you're thinking about that puzzle, I'm going to talk about how we can figure out which thing we have selected. So I'm going to make a new variable that's on this object. And it's going to be called, let's just make it a string, so a word, just for now. And we're going to call it selected tool. And I'm going to put a really special word before it, which you're not going to use very often. So if you're ever not sure if you should use it or not, the answer is probably no. Static is not a very common. I've used it, I think in Space Princess we use it like not much at all, like maybe 4 objects have a static variable on them. And what this variable means, or sorry, what this little bit of this word means, but when it's before a variable, is it means there's only ever one, which sounds a bit weird, right? But we have 3 tool selects. So we have 1 on the shovel, we have 1 on the watering can, we have 1 on the seed. We've got 3 of these ones. But this means if any of them change selected tool, it changes for all of them. Now, why do you think I might be doing that? Probably because I feel like I should have one of those screens. It's like, pause and have a think. Do you know why there might be only ever one selected tool? I love that, actually. Maybe I should add that in. So in this case, we only ever want to have one selected tool, right? There should never be multiple selected tools. At the moment, we're actually not saving a selected tool at all. We're making it grow larger, but we're not selecting it. We're not saying what it is. And we have a secondary bug that's just making them all select at once. We're on one click, which is a problem. So we're going to solve both those problems. So selected tool, what we can do with that is we'll just say down here, select shovel. I'm going to rename that to just select because it's not just on the shovel anymore, it's on different tools. So just select. I'm going to say selected tool equals, so I'm going to put in name. So that will get the name of the game object that is the script is attached to. And I'll also say, I'll tell it to debug log the selected tool. So it should print out to us what is being selected. So let's have a look. So click. Oh, it did a bunch. Okay, so shovel, seed, shovel. Oh, we have that. This one here, we don't want that anymore. Oh, so the collider name. That's okay. I'll comment it out, but so you can re-enable it in your own version of the code. But we don't need that for now. So we're just going to see. So it should tell us just what the selected tool is, basically. Yep, perfect, Doom Bunnies. So come back to that. So there we go. So seed, watering can, shovel. Great. So that seems to be working correctly, but we can't really tell because we still have that bug. So Doom Bunnies has suggested, can we see the collision check? So let's jump into there. So here's the collision check, and then said, the raycast, is the raycast just checking that it's hitting this object rather than anything? And it is not. That's exactly what the problem is. So it's just checking if it's hit anything. So we actually need to put another if statement in here. So if the hit collider, so if the thing that the collider is hitting is something, then select. So there's something we want to put in it because we're now checking this against this object. Is we can say that if the collider that was hit is this game object's collider, or actually we could even say if the hit collider game object equals game object. Now it seems a bit weird, like why am I doing game object equals game object? When I just write game object by itself, the same thing when I wrote transform earlier, or even here, it's actually shorthand for saying this dot game object. So I'm saying specifically this script, what game object is attached to this script. Whereas here, it's the hits colliders game object. So I've shot a raycast into the world, or my mouse down. It's hit the collider. We're checking the collider that was hit. We're getting the game object from it. And this double equals is a comparison. So whereas the single equals is an assignation, so we're putting the thing from the right into the left, the double equals is critically different. And it's asking instead, are these two things equal to each other? So hopefully with that code in there, that should resolve the problem we had. And hopefully some of you can see there are actually much more efficient ways of writing this code. Why are we using Raycast instead of Canvas? Good question. In this case, I want to demonstrate Raycast, and I also want to avoid using Canvas because it has all sorts of kind of other implications of using the UI system. So Canvas is a part of Unity's UI system, and I just wanted to avoid that for this lesson. And we kind of also need to use it for the the world. And like we could build the whole game in the UI, but it's just a bit of an odd way of doing things. So instead, we've built this kind of Raycast system, and we'll work on making that modular for future use in the rest of the game. That's a good question. Okay, so let's see if this resolved the bug. Yes. Still a bug. And another bug. Uh-oh. Okay, we've got two bugs here. So the first bug is we select something and the other one doesn't become unselected. The second bug is, this is more subtle, we can't click on the seed because of what's happened with the watering can is, its collider has become super large. It's become too large. Cool, so let's resolve both those bugs. All right, what was the first one? They keep on clicking. Okay, so they keep on, all of them are affected. So what we have to do now in select is we need to also deselect, right? So if we're selecting them, we also need to deselect them. So what we could even do, so this was a string previously. We could actually be kind of cool about this, and we could make this a tool select. So this seems like, what's a word? And what this is going to be is instead of just having a string that saves a name, we're actually saving a reference to this object, this script in here. So instead of saying name, I can just write this. So this script for whatever object it is. So if, for example, we click on the shovel, it saves this version of our tool select script into that static variable. So selected tool is this, and then we're going to say debug log. We don't need debug logger anymore because we know that is working. But we do need to, before we do it, deselect the old tool. So selected tool.deselect in here. And this is me kind of, again, the way I work is I'll kind of forethink what I need. So now it's going to be like, this function doesn't exist. So now I'll go ahead and make that function. Deselect, like that. So we know what select did. Now we need to make deselect do the opposite. So let's transform local scale equals vector3.1. So that's what it was before. They start at vector3.1, so the 111 for the scale. And then we make them larger to the selected scale when they're selected. And I'll put a comment here. So I'll say make the old selected tool deselect, and then select this tool. That's one other bit of code we might put in here, and that's just to check that the current, that it's not currently the same tool. So if the selected tool equals, equals this. So remember how we did that? So equals checks if it is the same. I'm going to invert it and say not equals. So the exclamation mark means if it's not equal to. So if the selected tool is not this tool, it's not the one where the script that we're in, then we do all these steps. There's no point in doing these steps if it's the same thing we've clicked on. Thank you, Kate. I hope you enjoyed it. I'll put up the video probably tomorrow or the day after. I'll probably wrap up pretty soon too because I'm getting some tummy rumbles for dinner. Cool. Okay, so we've selected the tool and then we deselect it. So we deselect that tool. Now remember, selected tool, this little thing is the apostrophe S, so it's then calling this function on it. So there's a few things going on. So what I might actually do to demonstrate, we'll see if it works. We'll fix our bugs and then I'll actually do a breakpoint because they're really cool at explaining how the code works. So we selected that. Uh-oh, we have a null reference. Uh-oh, null reference. Uh-oh, null reference. Okay, let's fix that bug. So it's upset. It's like, oh, what are you doing? This doesn't make sense to try and deselect something that has nothing in it. So the first time we start, there's no selected tool, is there? We start with nothing. So before we deselect it, we need to make sure there's actually something in it. So we can do that by saying if selected tool, and I think that's probably all we need to write. And that is shorthand for writing if selected tool does not equal null. So null is when a variable has nothing in it. So if the selected tool, when we start the game, selected tool has nothing in it, we just said, here's a variable. And it's not like things in the inspector where they kind of autofill with a value. Or I guess some of them can, but selected tool is a script, so it can't autofill. There's no idea of a default state. So it gets turned instead to this thing called null. And if you try to do a function, call a function on something that's null, the computer's like, oh my god, what are you doing? I've got no idea. Like, what's a deselect on nothing? What does that mean? So you have to make sure, first of all, that you're checking it's not null. And this should catch that error. So let's see how that works. Looks good. Hey, look at that. So we can get to the seed, but only when this one isn't large. Okay, so we know that that's a bug because of the collider. So what can we do about that? And there's one other minor bug, but I'm not too fussed about it. I don't think it's too big a deal. So what if when we select an object, we actually disable its collider? So if we play this again, and we can demonstrate, you can always test this stuff in the editor first before you code it in. So the bug is that now we can't click on the on the seed to select it. So if we say check the watering can, and we turn off the collider, so just manually turning it off. So this is while the game is running. The game is still running at the moment. Now I can click on the seed. Of course, now I can never click on the watering can again. So it's not perfect. So how we go about doing that? We need to have a reference to the collider. So this is, so far we've accessed the transform of an object. Here, transform. And transform is a nice and easy one to access because guaranteed every game object always has a transform on it. But it's a little bit different for other components because game objects might not have them. So what we can do is this get component, like this, get component. And in here we can type the type of thing we want. So I want to get the collider 2D, like this. And then the dot to do something to it, I'm going to set enabled is the one I was. So as you can see, I was like not sure which one it was, like active or set active or something like this. But the word for it is enabled. And again, that's something you can look in the docs for. So you can search up collider 2D, and it can tell you all about what it can do. And it's a type of actually, even if we go to it, I think it's a type of mono behavior, which means it has. So mono behaviors are like everything that can be attached. Actually, no, it's not mono behavior. The script's a liar. Mono behaviors are a type of component which it's in inherited members down here, enabled. So click on enabled, behavior.enabled. So everything is a type of behavior. So everything that you can access has a behavior. Good question. Doobunny's asked, do we want to be able to turn off the tool by clicking on it again? By clicking on it again when it's selected. Yes, I think that is what we're doing. And then, yeah, we need to, so we turn the collider off. We have to turn the collider back on again as well when we deselect it. Is that right? Am I understanding correctly? Yeah, just like follow up on that. Okay, so in this case, we deselect. So we're going to get the component that's the collider on this object, and we're deselecting it, so it's turning off. So we're going to turn its collider back on. And over here, where we are selecting it, we're going to turn it off. So get component enabled. False. Now this means we shouldn't have that bug anymore. So let's just quickly check and see. Yeah, look at that. Awesome. And you can see on them the box collider. So I've got the watering can selected. You can see as I click off it, it turns it on. I click on it, it turns it off. Beautiful. Just like that. Sweet. Poof, it's taken us a while to do this, hasn't it? Step by step, little bits at a time. Hopefully it's been quite detailed for you and given you a whole overview on how this stuff fits together. So I do want to get these plants. Planted before I leave, before we end this session. So we need to probably be able to select this, which we can do now. Fantastic. And now we need to do the same thing. So check if we're clicking on a bit of dirt and then dig into the dirt if we are. So let's go to our dirt quickly, because again, we can simulate this stuff before we actually try programming it. So I'm just going to see what it looks like if we change the sprite of the dirt to be the hole we made, like that. So it looks a little bit not great. We can solve that by moving everything down a little bit, probably. So if we grab all of the top dirt and just shuffle that down, we can see when we replace this with that kind of looks okay. Not super bad. And then we'll have to kind of move it back up again for this. So yeah, okay. So there's a few ways we can do this. All right, so let's have a look at making a new script on the dirt. So I'm going to call this dirt script. Or maybe just like dirt manager. It can be the plant, I mean, dirt. What's it called? Dirt. That'll do. Good question. Okay, so line 32. Let's have a look at that. Line 32, good question. Does it matter if there's no curly brackets after the if? That's a really good question. It's a really, really good question. So, really annoying shorthand thing a lot of programmers do, and code a lot of programs allow as well, is that for a single line if statement like this one, now keep in mind this is commented out. So as far as the computer is concerned, this line doesn't exist, this one here. So we can pretend that doesn't exist at all. The computer just ignores it because it's commented. For a single line if statement, you're allowed to not have curly brackets. You can do that. But I do recommend you don't do it, and I probably shouldn't have done it either, because it's very easy to say add another line here that does something else. Like say I did put the debug log in here. Now this isn't going to work anymore. The selection, it will debug log this line, but this is actually acting as though it's here. So be really careful with curly brackets. Make sure as much as you can, always try to put them around your if statements. And when you're really comfortable with code and you're sure about it and you're fine to debug this kind of any weirdness that might happen, feel free to be lazy like me and not do that. But try not to be lazy like me. Like it's not good. I think I've kind of solved enough problems now that it's easy for me to debug, but I definitely remember when I started programming, it was a huge pain to be like, why? What's happening? Oh, another actually common one that I've seen and I've done probably a few times when I was a lot younger, well, a lot of a new coder, is putting a semicolon at the end of an if statement or the end of a while loop. And actually now, like, it's giving me an error. It's like, what are you doing? It's like, mistaken. You've made a human. You've done bad. If you're in an editor that doesn't give you an error for that, this is super annoying, because basically what it's saying is it's as though you've got a blank line. It's as though you're doing this. And then curly brackets can exist on their own. So then that's kind of almost as though it's like this. Let me just get that back there. So it's kind of like that's what's happened. You just have this if statement that does nothing, and then you have this code just always running. That's what happens if you forget, if you accidentally put a semicolon at the end of an if statement. Cool, so dirt, we've got our dirt script. Cool, so let's open it up. So now we've got two scripts going, which is pretty fun. So a second script. And you know, I'm just going to copy and paste some of the code from that because it's pretty good, this code here. And that goes into our update function. So this is to tell if we're clicking on it. So just like before, we're just checking if we're clicking on this particular object. So is this object, whoa, I've still got that curly bracket, that line there, whoa. Whew, that could have been bad. Okay. Got that semicolon there, whoops, okay. Sorry, just had a little doggo trying to scratch the carpet, which is a new one. He wants attention. I've been at the computer way too long. Okay, great. So this is the same stuff we had before. Just copy pasted it. Now there are neater ways of doing it. So we could actually package this up into one nice to use little function. So maybe I'll do that just as an example because it's kind of cool. So I said before you don't really tend to have static variables much, but what I'm going to show you now is actually a whole static class and a static function. So I'm going to call it utility, and it's really important to note that this class is never going to exist on an object in the world. This is not what this class is about. This is like a helper class. So I'm going to delete all of the preset stuff, and I'm actually going to delete this thing that says mono behavior, and I'm going to write the word static before class. So like I did with the tool select, I wrote static here. I'm now writing static before the class. So I'm going to copy and paste this code into it. So basically what I'm trying to do is make this code here, which is quite complicated. I'm going to try and make it quite modular. Oh my goodness, those are strange brackets. Let's see if you'll auto fix that for me. No, you don't want to auto fix that for me. Tragedy. Oh, I know why. Okay. Let's put that in a function first. Okay, so I'm going to call this, let's kind of summarize what this is doing. So this is check if I'm clicked, basically, is what that's doing. So let's call this like is clicked. Let's just call it that. And we'll put all this code in here. It's got a curly line. It's like you can't declare instance members in a static class. So instance members are kind of like what we've been doing with everything else here. Just void select. Anything that doesn't have the keyword static is an instance. And that kind of means, so tool select, you can think of this code we've written as a blueprint. And then when we actually put it into Unity and we put it on objects in the world, that's when it becomes an instance of that blueprint, or an instance of that, or a cake made from that recipe, you could think of it. So in this case, it's like, what are you doing? You can't have things that are non-static. And static is almost as though there's no such thing as an instance for it. It's a weird concept because it's not quite, it doesn't really quite map to the real world in a way that makes sense. But the idea is that it's always the same for every case. You can't really have an instance of it. There's no such thing as actually making a utility object. That's not a thing that ever happens. In this case, it's more like a helper kind of thing that will assist us as we go. So all we have to do to resolve this problem is just write the word static. And that's just because I made this a static class on purpose, because I never want to have to instantiate it. I never want it to exist in the world. It has a very specific purpose. And you could not have that in there and still do the same thing. But again, just like we did with the private variables, it's a way of keeping everything safe. So by making this a static class, we're forcing other programmers who might be on the project, or future me, of course. Future me is probably a horrible person. So let's make sure that she doesn't accidentally try to instantiate this class that shouldn't be instantiated. Instantiating is just making it exist on an object like this, or making it, declaring it with a new keyword or something like this. Okay, so static void is clicked. So if the mouse button is down, do some stuff. So the only thing that's actually special, the only thing that is really critical here is this. This is the thing we don't know in this particular instance. So we want this to now take a parameter, a game object, because that's what this is comparing. So we're getting the hit thing. So get for a hit thing, get the game object from the hit thing, and then check against the game object. So I'm going to say, I'm just going to call this go. It's my little shorthand for game objects, go. I'm going to say if it equals go, then, well, select doesn't exist anymore. It's a weird concept in this abstract utility class. I'm going to write instead return true. That's going to give me a little error, and I'm at the end of this going to write return false. And then here where it says void, I'm going to replace that and say boolean, or just bool, sorry. So what this has now made is a little function I can call that will return true or false. So if I put this into, I'll put it in action and you'll kind of see what's going on. For those who don't know what bool is a boolean, so a yes or no value, a true or false. In basic, like in fundamental computing, it's really just a 1 or a 0. It's on or it's off. So often in computing, like in C and C++, you might see defines, which are kind of like variables but set in stone, that define true as 1 and define false as 0. That's your fun fact for today. If you ever see 1 and 0 being used in a kind of Boolean situation, 1 is on and 0 is off. Cool. So we want to replace this code because this is really messy. So I'm just gonna nuke it to here. I'm going to put is clicked in here instead. Get rid of all that. And let's make sure we do have our curly brackets as mentioned before. Good. And when I actually run this function, like the way I run these other functions here, so deselect has those brackets on it, I have to put the correct parameter into here. So is clicked also doesn't exist, so probably it hasn't compiled yet. It could be a problem. So I'll jump back, actually comment this out for now, and I'll just let this compile it and see if there's any errors, because that could be the problem. So it's still thinking, it hasn't cleared it yet. Maybe that error is going, no, it's my bad. Oh, because Dirt has the same code. Okay, right, never mind. So that should then compile. Beautiful. And now back in tool selects, I should be able to have if is clicked. If utility is clicked. There we go. That's better. And now it has a different error that says game object is inaccessible due to its access protection level. Okay, cool. So that goes back to what we were saying earlier about public and private. So the problem is that this is a static, this function exists, but because it's not public, my other code can't access it. Yes, thank you, Jim Bunny is on the money. Okay, so let's see. And now it's like there's no argument. So you can see when you hover over it, usually gives you pretty good tips on what you've done wrong. For any kind of static utility class like this, everything should always be public. And that was good that I forgot, so I could demonstrate that. And it also shows that public and private and protected and all the different access protection levels don't just exist for variables, they also exist for methods. Okay, so is clicked, we're going to put the game object in there, so we can just write game object, and again that's shorthand for this .game object. It's the same thing. So check against this game object. And now we have this, all that code we had written in there has just become this one line, which is pretty good. And you could imagine you might, if you made a whole set of these utility functions, you might call them input, or might call them mouse info or something. And that is actually pretty much exactly, so this is hopefully a cool thing to discover, that that's pretty much exactly what these things are. Input.getMouseButtonDown is basically what we've just created here with the utility, except that the Unity people have made that in the back end. So we can't actually access their code and see how they've written it, but you can understand how what they've done is similar to what we're doing now with utility, if not almost the same as a static class. It's a pretty advanced function anyway, pretty advanced thing. Okay, cool. But this means now we have this cool function, so we can put this on the dirt. So if the dirt is clicked, what do we want to do? Maybe we want to turn it into the whole. So what we'll do is we'll make some new public variables. So again, they could be serialized. I'll do it the right way. Serialized fields. Sorry, I'm just reading Kinrax's question. No, there's no particular reason other than just to demonstrate making a static class in this instance and keeping things kind of simple in their own way. So that was the question about extension method for the utility instead. Okay, so we can use serialized field for sprite. So I'm going to put some more sprites in here. I'm going to call one of them, let's call it flat. And the other states are, there's a hole, and then there's a mound. So those are the three states that it could be in. And we're going to say when it's clicked, we want it to become the whole. So let's put those when this compiles onto this dirt. I haven't put the script on yet. Whoops. Did I put the dirt script anywhere? Dirt, let's see. There we go, this one here. So let's actually remove it from there and instead apply it to all of them. So new dirt script. And there's a much nicer way of doing this, which I'll show you as well. Serialized field. Oh, and I'm missing a bracket at the end. There we go. Update. Yeah, okay. There we go. Okay, and then we popped up with that. So put the hole there, the mound, and the flat. So we've locked in all those three sprites. And if it's clicked, we're going to change what it is. Now, in order to change a sprite, just like the other ones, we have to get the sprite renderer. So we can, and like we did before, we used get component like this, but actually this is quite an expensive thing to do, using get component. You don't want to do it, if you can avoid doing it, you don't want to do it. So what I'm going to do actually is make a new private field. So it's private because no one else ever needs to access it, and I'm going to call it the sprite renderer. Well, sorry, it is a sprite renderer. I'm going to call it the I'll call it the S renderer, like that. And where we also had the start on some of these, I'm going to make one on awake. So it's as soon as it exists, so before even start is called, just on awake, I'm going to put in the S renderer the sprite renderer, like that. Now if I want to be really kind of correct about doing this. I can also guarantee that this class will only ever basically has to have a sprite renderer on it in order for it to exist, and that uses this code called require component, little Unity tag thing. So require component and then type of. So what type of thing is it? And it's a sprite renderer. So we'll pop that in there. Cool. Okay, so sRenderer. Now in here, I can say sRenderer.sprite, so I can access it straight away, and I can make that equal to the whole. There's a little bit more logic we have to do here, but that'll do for the moment. So let's just see if that works. Oh no, nothing happened. What am I missing? Let's have a look at our dirt. There's something else it should be requiring, but it doesn't have. And it's a collider. So box collider 2D, there we go. So now we can click on them. Whereas before we couldn't because it had, as I mentioned earlier, there's no physicality in the space until you manually put one in there. There we go, so now we can click on it and make little holes. Sweet. I don't like the way that that sprite has little edges, so I'm going to just quickly jump in and get rid of them. That's this one here. And I'll do the same thing for this one because I suspect it'll have the same issue. Frustratingly. Okay, there we go. Apply. Beautiful. Okay, so what's the next step? Now we know we're clicking on it, but we don't necessarily have to have a tool selected, so we have to actually check which tool we have selected in order for this to work. So at the moment, it doesn't make a difference at all. I can keep clicking it, nothing happens. So how do we get that information? Now we're on this cool thing of working out, like, how do we actually get information from different objects? So if we go to the tool select, we want to know what the selected tool is somehow, and we want the dirt to know that, because it needs to know it when it starts to do this check. So you could be thinking, okay, let's do the static thing again. And it's like, well, we could, but it becomes a little bit messy. As I mentioned earlier on, you want to avoid static. You don't want to use it often. You might use it in the case of utilities and stuff like this, and you might use it in the case of like this special instance of where you only ever want one tool selected. But like really the proper way for me to have written this code, instead of writing it as a tool select that goes on every single object, probably instead I should have written it as a tool select master that knew about all the different objects it could be, and then it managed them from there. So rather than having this script that's written multiple times on the different objects, it would just be the one that does it. So maybe we will have another static, because this one's already static, so we can already access it. So what we kind of want to do is have a static. We want to be able to access this from the dirt, just like we could access the utility from everything. So we can make this public. This is like the quick way of doing it. Say public if you're prototyping and you don't really care about the stability of your code. You could just chuck that in there and then you could check. So then in here, in our dirt, we could go if selected tool, and we have to get the name of it. And this is also a thing that's a little bit like not a great way of doing it. If the selected tool is the shovel, for example. Shovel. Sorry, and that should be tool select dot selected tool. It's a shovel. Then we can turn it into a hole. So this should solve the problem, but it's not a very safe way of doing it. So if we select that, it doesn't do anything. If we select the watering can, nothing happens. If we select the shovel, it works. Sweet, so it works, which is the most important thing for prototyping, just check it works. But it is kind of dangerous. And the reason for that is that some other bit of code could change the selected tool, and that would make this whole system go out of whack, because this whole select and deselect stuff is really reliant on it being completely accurate. So if for some reason the dirt changed the tool, like say the designer decided, oh, when you make a dirt, like make it a hole with the dirt, then you should automatically change to the seed, right? That might be a design decision. That would throw this whole system out of whack. But the code would still, at the moment, allow a programmer to go in and make that change, to just say, in the dirt, let's just change it. So I'll do a little bit more just to make this clean, and then we'll, I think we might wrap up because it's been quite a long session, and then we'll come back to it maybe in a few weeks. I'll run the second half of this one, which should be a bit more exciting because it'll actually have like making the plants grow, which is what we're all waiting for, especially me. Oh, I just want to grow plants. Okay, so let's wrap this one up a little bit, and then we'll call it a night, or a day, I guess, or a morning if you're not from Australia, or not from the East Australian time zone. Okay, where are we? Right, so dirt. So this is not a very clean way of doing this. In tool select here, it's not very clean. So what we could do instead, just like we had a public static method here, is we could make another static method in here called a getter. So I might put it at the bottom. No, actually, I'll put it at the top. I'll put it at the top. So you tend to want to put the public things that other scripts need to know about at the top of the code, so that other programmers who might need to look at them can find them very quickly. So I'll put it here. Say public, static, and I'm going to say tool select. So everything is, oh sorry, static public, public static, static public. We'll do static public just to keep it the same as up there. Tool select. I'm going to call it get current tool. And that's actually a function. And you can see if you hover over it, it says not all code paths return a value. So just like we did with the utility where it has this little return true, return false, because it's returning a Boolean type, this one is returning a tool select type, and it can just return the selected tool. And that way this doesn't have to be public, it can be private. And it's read only. So if someone else wants to change the tool, they can't do that. They have to do it through this tool select system instead. Okay, so selected tool, we want to return the selected tool. Have I got a dog on my cable again? I do. Would you believe that? It's the third time. What a wonderful boy. Okay, return selected tool. Beautiful. And now we should have an error in the dirt where it's like, I can't access that anymore. And that's awesome because that's our system kicking in saying, you can't do that weird stuff. And I can replace that with the function we just wrote. So tool selects get current tool function, which is this one here. Beautiful. Great, so let's see if that still works. Nothing, beautiful. There we go, working, wonderful. So really quickly we can add in actually planting the seed because that's obviously what we're all waiting for. And I might introduce something a bit new. So here we've got if the tool select the current tool name is shovel, do this thing. So I could put another if statement in here that pretty much does the same thing but turns it into a mound instead. And we'll have to put a little bit more logic in here. So this should be the seed. So if current tool name is shovel, turn it into a hole. If it's a seed, turn it into a mound. Easy. And we'll make this a bit neater in a moment. So, seed. Oh no, I broke it immediately. So we see some problems. One is that it's not actually locking the stage that we're in. So I shouldn't be able to plant a seed directly onto the dirt that's not been shoveled, which we can solve. So, and the other one is that I think we could go backwards, which we might not want to do. But maybe it's okay to be able to shovel out a seed if you don't want it. Maybe that's fine. So this is kind of hacky. There's a nicer way. There's much nicer ways of doing it, but I'm just going to show you this because again, it's about prototyping, getting it in there to begin with, and then you can neaten it up later. And that's definitely how I program. Different programmers work in different ways. You might want to do things really cleanly and correctly from the get-go, or you might do it the whole thing really messily and then come back and clean it up if you need to. Though I do recommend trying to clean it up as much as you can as you go. Okay, so basically we want to say that we don't want it to. So we're not just saying if the current tool is the seed, change to the mound. We actually want to add more to it. So I'm going to add an and in here. So double ampersands is the and symbol. The inverse is, well, not the inverse, but the other one is the double Oh, this is a British keyboard. I don't know where my... Oh, there it is. Okay. No? Oh my goodness. There it is. Okay. Sorry, my keyboard is UK and they have different... But my mapping in Windows is Australian. So I'm like, where is my pipe symbol? Anyway, this pipe symbol, which for you should be in the top right of your keyboard. So I'm just reading these things. Yep. Yeah, so we are planning to change it to a switch. But we'll do that in a moment. Okay, so we can put double and or pipe symbols in here. The pipe symbol, sorry, I've just been dancing around my words, I'm getting tired. Double pipes are ors, so an or rather than and. So in the case of this, we're saying if the current name is the seed and, so we'll take this bit of thing, I'm going to say, and this current sprite double equals, so we're not assigning it, we're comparing it, so that's the magic of the double equals. So if the current tool name is the seed and the sprite renderer is a hole, then we change it to a mound. So let's see if that works. Oh, Doom bunnies. Oh, Doom bunnies. Okay, so good, we can't plant a seed straight in. That's really great. We can dig holes and we can plant them. Awesome. So we can see that the offset of this mound is wrong. So we could do some fancy code to make it actually like kind of pop up a little bit. We could like put an offset in the programming, but actually much easier is to jump into the sprite editor. And the game is still running at the moment, so hopefully this will update in real time. Oh no, edit disabled. There we go. Okay, fine Unity. And I'm just going to move this point down a little bit. So we could even look at this and make sure that always there's a kind of the correct kind of offset between the bottom of the ground and stuff like this for this to look right. So we'll see how that goes. We'll apply that. And then you can just tweak exactly where that is. So this thing here represents the pivot point of the object when it's placed in the world. So if you put this at 0, 0, 0, this will be the middle of the, this will be exactly where it sits. So for a lot of sprites, so for example, for my plants, it might actually make the most sense to put them like that. So right down the bottom of them. Should I put it a little bit above? So there's a little bit of overdraw like that. That's the pivot point of it. And for the water, I might put it, whoops. For the water, I intend that to come out of the, oh, I can't move you, that's weird. To come out, oh, now I can move it, that's very strange. I tend to come out of the watering can, so I'll put it here, like that. And it depends, of course, on what you're making, but often characters will have them on the bottom, just like the plants do in this case. Okay. So we dig some holes, plant a seed. Oh, look at that, it matches up, that's great. Beautiful, not perfect there, but that's okay. Fantastic. So now there's something that that I haven't talked about, which is a really core part of Unity's feature set, as well as the, so it's like component system and game object system. And it's that you can actually kind of save these things called prefabs into the system, and they make it really easy to redo stuff and to remake new levels and things like this. So at the moment I have this normal dirt, and all the normal, I've like been selecting all of them at once in order to change them. But what if our level was more complicated and there are all these different places? That would make it really hard to be able to jump in and like tweak a variable on one of them and have it apply to all of them. So what you can do to manage this, and it's a really, really lovely system, is you can create a prefab. So you can either do that by going to create in here and then prefab here. And you can see there's this empty prefab, and I'll call it dirt pile, maybe, or just dirt. And it's gray to tell us there's nothing in it, or white. And then I could drag the dirt pile into it, and it becomes a little picture of dirt. Or if it was a different game object, it would turn that little cube into a blue object, so I knew what it was, that it was now filled. And now if I put this in the level, I drag it straight in, you can see these are all pre-filled exactly like this dirt is. And you can also see that that patch of dirt has turned blue in the hierarchy there to show us that it's a special thing. And in addition to that, if I select it and I go up here, you can see I can select, it has prefab, and I can select it, and that jumps me to this dirt here. So say I wanted to change the starting image, so I want it to all start maybe with a hole instead. That's now changed all of them to now start with a hole, or change with a mound. They've all changed now to have that mound. Beautiful. So you can see how that would be really, really useful. I don't want it here, obviously, but I do want it across the top. So I'm going to delete all these old ones and then just copy paste them again like I did the first time. Just move them across. And now I know if I need to change the dirt prefab for whatever reason. Actually, I might just move them all like that. There we go. If I need to change them, then it should be pretty straightforward to do that. I'm not very good at counting, am I? There we go. Super. So let's just check that they still work. Oh, they have the wrong image on them though. Whoops, but that's okay because the prefab is easy to change. So we can select the prefab in here. In the inspector, we can see it up there. So we'll just change it back to the normal flat dirt. Perfect. And then we can see that some of them are a little bit offset. So we'll just correct that. And you may have also noticed potentially that this dirt patch on the bottom is now being, some of the bits of it are being, so over here, like it's being clipped. So to resolve that, we can just change the sorting order of these. So I'll select all of these and order in layer here, this number here, is what tells the renderer, or the GPU in this case, which one should be drawn first. So sprites are done a little bit differently to 3D objects in that they tend to not worry too much about their Z position. So changing their Z position, it might make changes, but it might not. So it did make a change, but it can do some weird things depending on the shader you have assigned. So the safest way to do it is just to change that sorting order to 1. And then we probably want to actually, now I think about it, make the sorting order for that 2, and then the sorting order for the dirt, and I'll do it in the prefab 1. And that way the plants can be at 0, so they can sit behind the dirt mound rather than grow out of the dirt mound. Whoa, no! Something went wrong. Let's have a look in 3D. Let's see. Where's our camera? There's our camera. So that could be the problem. For some reason, I've managed to move the dirt right up to the camera. And changing the sorting order made that an apparent problem. There we go, that's better. Beautiful. So, shovel, making holes, planting seeds. I really want the seed to actually fall and hit it, but that's the thing for another time. That'd be really fun if you just like has a bit of physicality to it and bounces around. Okay, I think that's where we might wrap it up because it's getting a bit late over here. But it was really good streaming to all of you today. As I mentioned when I started, this is the first time I've streamed. So it's really cool to have this experience and have a couple people tune in and just kind of watch how you might approach a problem like making a little garden game. By all means, please send me some feedback. I would love to hear what you think, what you would like to see, if you'd like to keep watching these kind of things in the future, and what level, like if this is too complicated or if it's too slow, or if you want to kind of follow along and have a preset. Like I kind of had these assets up there, but I could obviously have done more and like already setting them up in the sprite editor and stuff like this, so I can send you packages before we start. Anything like that, I'd love to know. So send me an email, or get me on Twitter. I'm just Cherie Davidson. I'll put a link to that in the description a little bit later. Yeah, and we'll follow this up maybe not next Sunday, but the Sunday after. We'll see. Maybe next Sunday. Depends how we're going for time. So we can actually get some plants growing because I'm really keen to have that happen. And the one after that, assuming people are all still interested, then I might do like a dress-up game or a character creator or something, because that would be quite fun. We did cover, I'm just reading some of your comments now, we did cover quite a few like quite complicated topics in this, so if you're feeling a little bit overwhelmed, that's totally fine. The main thing about programming is just to kind of, I mean, I don't know about the rest of you, but I'm very much a deep dive learner. Like I spend ages not understanding what's happening, and then at some point my brain hits saturation point and I can just see everything, it like all makes sense. So if you're a learner like that, like me, then the main thing is just to kind of just keep on. And that's why I tend to explain more advanced topics too, because the little things like the way, like what is input, like what is tools, like all these things, what is input, where does that come from, why is it blue, why does it have a dot, like I need those answers before I can can really probably understand something. So if you're a bit like that, then that's kind of why I do the advanced stuff. And keep on at it. Like, don't, even if it's really overwhelming, do little bits and little steps. And I hope this was kind of palatable and not too much to scare you away. That would be my worst outcome, is if you're scared of code because of this. There's just like lots of breaking down problems and working out the steps to solve them, and you're probably all at a really great stage of just learning all the different instruments and all the different tools. Like, imagine you've started to learn to cook, and you need to discover how a pot works and how a stove works and an oven. You know, you need to know what the tools are before you can bake a really fantastic souffle or something. Yes, and Kinrex has a really good point back there as well, about sorting order, that it's pretty much random. So do make sure you set the sorting order, because it can be just super odd if you leave it as it is. And that's actually true of all code. So you might think that, like, we know awake happens before start and then update happens every frame, but we can't guarantee, for example, the dirt's awake happens before or after the awake of tool select, which might happen before or after the awake of some other code. You can never guarantee that with Unity. It's a bit funny. Okay, cool. Yeah, lovely, lovely to stream with you, and I'm looking forward to your feedback. Follow the stream if you are keen for more. If you are all keen to see more, then I will do more sessions. And I'll see you next time. Bye-bye.